at work as of officially a little over a month now. So I did 5 months out of work and been back at 1 month. And Doc says it'll take a year before my knee's back to normal. I fell through a floor, as Mike knows, and my kneecap decided it wanted to misbehave and go 90 degrees to the right. So I learned to appreciate my health a lot more. And if you don't think you like your job, spend 5 months delivering shoes and toilet paper for logistics and sitting in a wheelchair a little bit, and life changes dramatically. So I really have a renewed perspective and appreciation for what I do. All right, let's see if I can get the presentation back up here. I'm going to minimize this here somehow. Where is my button? I may need my technical specialist here if he can come in here, and then we'll get the screen back up, because I can see all of you. So far, I've got what, 3, 6, 9, 10 people on board. Is that right? You minimize, get this back. Okay. Is that it? No, I want to get the presentation back where I can see it. You guys see the first slide, correct? Okay. I just made that bigger instead of going back to my presentation where I can see. I'll need to stop and start over there. No. How about we do this?
Hold on a minute. Just hang.
Sure.
Don't get excited.
Oh, I'm not excited. I was excited yesterday. I was at work. So how many, while we're waiting on the screen share, how many departments do we have represented?
I know we have Mesa and Mike Zolan. He was out with us at the KTF Burns from Boise. Yeah. And him and I have been in touch ever since. So we made some long-term friendships from that KTF Burns. So that'll be good. I'm actually going to fly out there soon. I got to book my flight this week. So, and then awesome. Everybody introduce themselves.
Oh, that's great. Who else we got?
Chris McCarthy from Castle Rock.
Nice to meet you, Chris. Thank you for coming.
Thanks for having me.
We appreciate it, sir. I'll just chime in. No rhyme or reason here.
I got my buddy Rob Christensen from Boise. He's at Station 16. I don't know if he's there right now. Maybe he's on a call.
No, I'm here, buddy.
Oh, there he is.
I got my firefighter Jeff Challey, my driver Mark Austin.
Oh, that's awesome.
Yep. Thanks for having us.
Oh, thank you. Anybody else? You guys see the first slide, and we're going to get started, I guess.
Yep.
All right. Well, I appreciate you having me. As Chris said, it's just an honor for me to do this. I've been blessed to hang around some wonderful people, and been involved with Project Kill the Flashover now since 2011. It's my father's project. I joke and say that I've been in the fire service a long time, as far as since I was a little kid, but 17 years career. But I always joke and say that he started the Fire Behavior Project when he became a grandpa. All of a sudden, I became important. So we like to joke about that. But so a little bit about myself. Chris told you that I'm from North Carolina. I'm a captain on an engine company in Charlotte, North Carolina. I'm involved with KTF Burns, which serves as I serve as the deputy chief and over the test burns portion. That's a new position for me. Been involved with the thermal imaging aspect for quite a while now. I'm also the founder of Bringing Back Brotherhood, which I have two passions: fire behavior and firefighter behavior, which is all founded on my faith and my family. I don't know, can y'all see that slide with my daughter at the top there? Yeah, so she's our motivation. She loves the fire department. So we're all muted, gentlemen, because I can hear some feedback somewhere. So why are you here today? What is it? What is all this about? Why are we throwing another phrase out? I'm sure you're tired of hearing the acronyms, new things you've got to remember and things you've got to throw into your mind for size up and whatnot. What we're going to talk about today is tactical thermal imaging, what it is. We're talking about giving you a new perspective for something you've been looking at for a long time. Most of the people who take this class are crew leaders, company officers, chief officers. You know, they have a ton of knowledge, and some of them have far more knowledge than I do. So what we're learning today is looking at the fire ground, an actual incident scene, from a new perspective to gain more information. And we're going to focus on 3 perspectives: your tactical perspective, which you currently do a great job of in the fire service, and the 2 other sides of it, the meat of it, will be the thermal perspective and 3-dimensionally. Okay? So what does that mean? Why is that important to us? Currently, we do a great job tactically on the fire ground. But one of the things you hear people talking about all the time is being able to read the fire, read the smoke, read the building. We talk about reading smoke from, volume, velocity, density, and color, but one of the things that's missing is being able to accurately diagnose the thermal severity of the environment. So we're going to talk about today how you can do that from different skill sets that you currently already do, and we're going to enhance what you do. We're not going to discard what you do. We're not going to throw out the baby with the bathwater by any means whatsoever. We're going to look at what you already do, how you can enhance it, how you can gain more information from different skill sets, and such as a tactical 360, which is an enhanced version of a 360, how you can identify and manage the flow path. I'm sure you've heard that term a lot lately. And you're going to be able to see it a lot better by the time you're done with this class. Also, we're going to look at how we can enhance our fire attack and our search methods, which is the bread and butter of the fire service. We're here to save lives and property, correct? That's what we do. So why would we not want to embrace a tool that helps us do it better? So we'll talk about how we can do that. So why do you need this? I'm a good aggressive firefighter, been around the block. I've got my certifications. I'm in an aggressive training department such as Chris's department. Why do I need to use a TIC from a tactical perspective? Here's the main point, gentlemen. Your minimum thermal protective performance of your gear equals 17.5 seconds until you receive a 2nd-degree burn. Okay? The gear you wear is excellent gear for the most part across the country. The problem we have is we cannot feel the heat anymore. We cannot accurately diagnose the thermal severity of the environment we're in, and the majority of our PPE begins to break down at 500 degrees or less. And we're entering environments that are far above that and chugging through it without opening nozzles, without cooling the environment, and wondering why we're getting burned or worse. So today you're going to be able to learn how to accurately diagnose that, accurately control it, and be able to make a difference in somebody else's life and your crew's life. Everybody see the slides okay? Give me a thumbs up. Good? Okay. So I love Paul Combs. I don't know if y'all do, but this is making the point. Tactical TIC use can prevent tactical mistakes, but the only way we can do that, I don't know if you guys use laptops and routing software on your trucks, and people get reliant on turn-by-turn directions. We don't even look up directions. We go on trips anymore. So the tendency is we start to over-rely on technology. What I want you to understand today is tactical TIC use is not a replacement for the fundamental components of our training. It's not a crutch, nor should it be totally relied on. You shouldn't get tunnel vision on it. It's not the gospel. It's a device and a technology to help you do what you do and do it better. I think Paul does so much with a picture. He shows 3 firefighters completely disoriented in a smoke-filled environment when, guess what? The TIC quit working. Imagine that. I mean, how many of y'all got wonderful cell phones and computers that quit working when you need them, right? So if we rely on it, complete 100% reliance, and we get in and we're supposed to be leading our crew, and all of a sudden the camera quits working, are you oriented? Do you know where you are? Have you diagnosed that environment? Do you have an area of refuge? Do you have secondary means of egress? Have you counted the lengths of your hose line? Do you know where you are? That's important for us to stay on, okay? So let's define the problem. How many of you crawled into a working house fire trying to find the seat of the fire, and when you got 8, 10 feet away, you were able to see the base of the fire like this? Okay. Would you rather see that? Would you rather see this? You've never been in this house before. You've done a 360. You've read the building. You've looked at the windows. You've got a good idea of the layout of the fire. But I can open the front door of the house or the door or window I make entry with, and when a properly trained firefighter with tactical TIC use be able to accurately diagnose where the fire is, which direction I need to go, where the fire is heading. I can locate the seat of the fire and see unseen hazards. I can protect my crews from thermal insult. And when I'm putting out the fire, I can eliminate hot spots from reignition.
Our engine guys are very quiet.
Somebody mute their microphone for me. Somebody's background noise.
Oh, we're not.
We're not necessarily ready right now. We're trying to get ready.
It's Justin Durkin. Could you make that for me, brother? Thank you. All right, so let's move to our next slide here. All right, that's the same room of the pictures you just saw. The initial picture you saw was a chair burning in the corner of the room in a KTF Burns project in 2011. And you see on the left, you see absolutely nothing. And on the right, you see the firefighters moving in. Let me go back. So if I'm trying to find the seat of the fire and I've got an active crew doing a search on the other side of the house trying to find a child, do I want to, keep searching, keep trying to work, trying to find this fire, taking a beating, or do I want to go straight to the source of it, put the fire out, and make a difference quicker? That's what we do. So for me, where this all began was in 2011. Let me go back one, and Project Kill the Flashover, when I started to realize that the environment we face is a lot more severe than I gave it credit for. Okay, and in our project, we use real fuel load, live fire environments with couches, chairs, sheetrock environments. And when I was assigned as a TIC crew leader, I saw the fire ground for what it truly is. It's a thermally dynamic and rapidly changing environment. The black turbulent smoke that I used to duck and dive underneath became 1,000-degree smoke that I realized, or 1,000-degree exhaust that I realized I was very close to flashover or worse. Now I'm supposed to be responsible for 4 other individuals' lives or more, and I was sticking them in that without cooling it off, without controlling that air track or flow path, and racing to the seat of the fire, betting that we could put it out before we got burned. Now, all of a sudden, I realized I can do a better job. I can do a better job with my guys, with locating the fire, putting it out quicker, and obviously finding people if necessary. So why is this all important? There's a good example of a turbulent, nasty, vent-limited fire. At this point, many of you say, well, this is interesting to me, but it doesn't apply to me because I'm an aggressive interior firefighter who isn't afraid to flow water. And that's where most of our problems come from, gentlemen, is that a lot of us are not opening the nozzle. But I would say to you, that's great, but are you aware that from 0 to 500 degrees takes minutes for a fire to grow, but from 500 degrees to flashover can take just seconds? Our PPE, our radios, our masks, all can fail at temperatures around 500 degrees or less. And once we begin to exceed the thermal protective performance of our gear, we begin to receive second-degree burns, and it's too late at that point. You can't cool yourself off fast enough. Any of you who've done gear studies or looked at firefighters who've been burned or had the misfortune like I have being contact burned, you understand once your gear is saturated, you're done. Game over. You've got to get out. There's no resetting our gear. So it's paramount for us, even as intelligently aggressive firefighters, that we not only apply our training and our skills, but we don't exceed the thermal performance of our PPE. In this class, we'll discuss things like go, no-go tactical decision-making, thermal cues that a firefighter should be able to figure out instead of burnt ears and penciling the ceiling, waiting on to see if the water comes back to them. Those are things that we have been using to gauge the thermal severity of the fire, but let's put it this way. We know how long our gear will last, brand new, out of the bag, inside of that environment. How many of you got gear right now that's not brand new, that's possibly dirty, that's possibly not in the best shape? Now I'm 25 feet, 50 feet inside of a structure, and I have those conditions, and I can crawl 2.5 foot a second, and my gear lasts 17.5 seconds. And what we're taught to do is follow the hose line back out the way we came. Now, if you look at the front door of this picture, and this goes bad, and I have a full exhaust of flame blowing out that front door, what am I crawling back out of? I'm crawling back out of a blowtorch. So we're going to talk about how we can change our mindset. We're not changing the way we do things. We're changing the way we see it. And therefore, you can make the appropriate decisions based on your department, your staffing, your resources, and the TICs you use to make the best decisions. All right. This class is tailored around a Bullard camera. Just so you know up front, I know several of you probably use different cameras. There will be other pictures and other information related to other cameras. I'm proficient with using approximately 7 cameras now. There are 7 NFPA approved ones. We did this for Chris's department in relation to they are using the Bullard T3 or T3 series cameras. So before I can understand or apply what I've got going on, I need to understand what I'm looking at. You look at a thermal imaging camera today, how many of you were taught were point, look at the temperature on the right, and that's what it was? Anybody been taught that? Some people have. And that is all that is the focal point temperature of that camera. It's not the whole big picture. So we're going to talk about the key attributes, your field of view, the modes and temperature modes, the associated color palettes of the camera, the resolution capabilities, distance to spot ratio, and emissivity, which is a funny word with a very big, important meaning. So we have to understand that everybody knows the use of their tools, whether it's a halogen, whether it's, you know, a hose line, whatever they're using, they know how to use it well. How many of you know how to use a camera more than just search and overhaul? We're paying $5,000, $10,000, $15,000 for these things, and we're not using them to their maximum efficiency. We can be using them to strategically improve our decision making and make a difference faster by using those fundamental skill sets. So that's what we're going to talk about. So do you understand the language of your camera? This is a picture of a Bullard camera shot inside of an interior of a structure. If I was just to ask you to look at this picture and tell me what you see, the majority of the individuals would say, I'd see a room at 300 degrees based on the color graph on the right-hand side. All right, so we strongly recommend that any fire department that uses TICs tactically, they have to develop their own training program in which the user follows their own same usage in the same mode. Most firefighters don't even know that there's a camera mode. There's functional modes and temperature modes. They need to understand the associated color palettes, what each color means at each temperature. Then they need to train the end users or the crew leaders, which are the ones that should be holding the cameras, to properly diagnose those critical variables and the circumstances that make it go into that mode. So you're starting to see, I'm hoping that there's a lot more than this than just pointing and shooting and figuring out what I got here. In the case of the Bullard camera, it has 2 temperature modes, 0 to 200 degrees and 200 degrees to 1200 degrees. Well, why is that important to me? Well, for your first mode is your high sensitivity, which means it sees a lot of stuff at very good detail at a lower temperature. Well, when it switches, look at all the information I can glean now. Does it, y'all see the slide that says language of the TIC with all the arrows on it? Is that correct? Okay. So now I'm looking at the screen and I'm saying, wow, okay, what kind of information do I have here? I can see, as number 5 arrow says, I can see which way the fire is, the fire location. We understand by studying fire behavior, if you've taken fire investigation and whatnot, fires create a characteristic V pattern. Well, look up here in the right-hand corner. Do you see a V pattern forming right there? Do you see a lot of red? Okay. By being a tactically TIC trained firefighter, I understand that the color palette of a Bullard goes from gray, yellow, orange, and red. Red being the most severe diagnosed temperature or thermal severity of that environment. I can now see 1200 degrees or greater, a large portion of it to my right. I can also see in arrow number 6 that that chair is starting to off gas. If you see the yellow on that chair, yellow in a Bullard T3 camera means 800 degrees, which means that surface of that couch is 800 degrees. Most combustibles in our house light between 500 and 600 degrees, which means it is about to light and contribute to flashover. So look in the upper left-hand corner. Did everybody see that EI symbol? Everybody see that? Okay. That means electronic integration. A lot of cameras will just have a triangle if you use another model. Triangle means lower sensitivity mode, which means you're at the upper end of that camera's ability to read that thermal environment. That means it is that the majority of that environment is 500 degrees or greater. Now the max temperature, if you see on arrow 4, this camera is 1200 degrees. Bullard does not read any higher than 1200 degrees. So now I see that, okay, the majority of this environment is 500 degrees or greater. What did we just say about our PPE? Anything above 500, it can start to fail. My mask fails at like 447. My gear starts to char at 572. My radios can fail at 350 or less. Do you think I might want to cool this environment off before I let my guys search that room? Now, I'm not going to argue nozzle techniques with anybody today. There's a lot of them you can use. But you got to look at this very tactically and say, okay, the focal point of this camera in number 2 basically determines the temperature of that color graph. And do you realize that that little focal point is a 6-inch circle in a Bullard? That's all it's measuring, is that little 6-inch spot. Wherever I point it, it says, okay, that's 300 degrees. How many of you, raise your hands, think that room is hotter than 300 degrees? Yeah, okay. Would I want to stand up in that room? Judging by what I just taught you. You wouldn't stand up very long. Okay, so now I understand that I need to proactively scan that room and move that camera around to get a bigger picture. If you see in on point number 7, you see the arrow pointing down at some yellow spots on the floor. That could either be some fall down flames from the ceiling or drapery, but most likely what you see when you start to see yellow or temperatures on the floor, whether it's carpet or wood, you're seeing radiative feedback on the floor. The ceiling's acting like a mirror and you're starting to see the floor heat up. Now, if I tell my firefighters to go in and do a left-hand wall search, and I'm doing a direct search here, and they go left, and I have them crawl across that, and whatever that is touches their knees and hands, they have a high likelihood of getting burned. So you've got more information than you had before. Point number 8 there shows you a TT button. On some of these cameras, they have what they call a thermal throttle. If you have one of those in your camera, that is a non-fire use option. It is for outside size up and overhaul, not interior fire attack. And we'll talk about that more in a little bit. So this is the language of the TIC. This is why we need to understand this. This is how much information you can glean in just a few points. And this is minimal information. We can get way more in depth. And you need to be able to rapidly make these decisions by looking at this information and saying, what do I have? Where am I going to put my stream? Where are my guys going to search? All of that based on your knowledge of understanding the language of this camera. All right. Anybody have any questions before we move forward? Just chime in. All right. So the Bullard T3 is what we're talking about. It has a high sensitivity mode, which is from 0 to 200 degrees, which means that pretty much everything in there is grayscale. Then it has a low sensitivity mode, which is your EI. You saw that in upper hand, which means it says 200, 1200, which if you look at the actual calculation, the way it works, it means the majority of that environment's over 500. Some cameras have what they call a super red hot feature. Bullard's one of the best ones that simplifies things. They said it best. You know, yellow is hot, orange is really hot, red is it's going to kill you hot. So they figured out super red hot. Anything in that environment that's 1,000 degrees or hotter, it automatically colors it red. So the firefighter understands red, stoplight, red's bad. Pretty simple. I give them big brownie points for making this very simple. And then some people have what they call electronic thermal throttle. We'll talk about that more and how you can use that to your advantage. And here's a picture of both. If you see the blue in the upper left-hand corner, that's called electronic thermal throttle. If I was doing overhaul or I was looking at, uh-oh, sorry, we got a little pop-up on the computer here. Hold on. If I was using this camera to do overhaul and I was trying to locate my hot spots, the thermal throttle, what it does is it looks at very specific points and it's very sensitive. Any of y'all familiar with photography and know what the word aperture means? What that means is it opens up and lets a lot more light in. So if my pupils are dilated, I can let a lot more light in, like in a dark room. So electronic thermal throttle, what it does is it opens up the aperture of the lens, allowing more infrared energy to come in, and it colors anything that's hot blue. And you can set the specific signature or severity of the camera, how sensitive it is from 0 to 100. Okay, it's really good for using for overhaul purposes, and it's excellent for if I'm doing what we'll talk about later, which is a tactical 360, and I'm having trouble locating any hot spots or trying to indicate where the fire is, I can use it for that. The other feature is the super red hot, which provides a greater detail of the fire. So when I'm in a superheated environment, most cameras, most people don't know this, what it does is you get less clarity and less resolution in higher heat environments. With the super red hot feature, it automatically adjusts and gives you, as I said before, anything over 1,000 degrees is automatically turned red. Anybody have any questions on that before we move into more of the meat of it? All right, so let's talk about the fun stuff, recognizing fire behavior. We've been taught, you know, NFPA 1403, we've been taught flashover can burns, we've been taught live burns, approximately what those temperatures are. But have we stopped long enough to think about how they impact us in our decision making? So when we look at rollover, it occurs at 500 to 700 degrees. We look at flashover, it occurs at 932 degrees to 1100 degrees. Backdraft temperatures have been as high as 2000 degrees. Fire gas ignition happens at various temperatures, but most of them occur at over 500 degrees. And rapid fire progress and vent-induced flashovers have been around 1100 degrees, also post-flashover temperatures as well. So why is that important to me? what time are you showing up at the fire? Are you showing up during rollover? Are you showing up when it just flashed or after flashed? Are you opening the front door and creating a vent-induced flashover? You can look at the fire's temperature now when you're reading the smoke, reading the fire, reading the building. Now you can look at it from a thermal perspective and get more information to judge what I need to do based on my resources, my staffing, and the skills I got at hand. So we talked about key attributes. We're going to talk about why that's important to you. Field of view and what that means to you is your camera has a limited field of view. If any of you have tried to take a picture of your family or friends, you've had to move forward or move backwards to get them all in the shot. The camera works the same way. Most cameras have a field of view between 37 degrees and 50 degrees. If you look at this shot, this is a picture of a vent-in or isolate search drill that was done at South Carolina Fire Academy through the eyes of a thermal imaging camera. Well, the actual camera footage, the big picture, is a helmet cam. So do you see how much difference you see by looking at, if I look at just the thermal imaging shot, all I see is the firefighter at the top of the ladder going into the window. And I can see a heat signature of the window that he just broke out where he's about to go head first in and search that room, which, by the way, they have a camera with him as well. Then I look at the helmet cam shot and I can see two sides of the building. I can see two firefighters going up the right-hand side. That's the safety line. I can see a photographer on the left-hand side. And that's through a helmet cam shot. That's not the human eye. The human eye sees a 270-degree field of view, where the best cameras on the market are between 37 and 55 degrees, average being 50. That means we're losing up to 233 degrees of perspective if I get tunnel vision and look solely through that camera. So I hope I have your attention. So what we're talking about is you looking at the picture above and tell me what you don't see. How many people have you seen put their mask on, come off the truck, put their mask on, pull the hood down really tight where they can't really see, and they diminish their field of view and they go charging up to the front of the house? Do you think they may have missed something to their right or their left? It's very possible, unless you train doing that you've diminished your field of view. You may run by a victim in the front yard. You may step on a charged power line. You need to have a bigger field of view when you're making these decisions. So most cameras, as I said, are 37 to 55 degrees field of view. What that means is the first number is the vertical number. It sees what I see top to bottom. The second number is the horizontal number, what I see right to left. So do you currently know what field of view your camera has? The Bullard that Chris has asked me to speak about has a 50-degree, on average, field of view. It's 37 by 50.5, which is about the average of a very detailed camera. So let's consider this from different perspective. You got kids, or you got a wife, you got family. You got one driving a Fiat and you got one driving a Suburban. Which one's going to see more out of their windshield? What do I want my 16-year-old in? I want him in the Fiat or I want him in the Suburban? You know, it depends on what parking lot they're pulling into, in my opinion, but you want to be able to see better. So if I'm in a Suburban, I can see a bigger picture. I can see things I couldn't see in the little tiny Fiat. So I'll have a better view of the road and the hazards ahead. The same thing with the camera. I need to understand considering the impact of taking a step back, just like a good incident commander understands that they don't need to be right on top of the scene. They need to back up and look at the whole picture and see different sides of that. So let's talk about that and how we can really hit home here. Here's a crew of firefighters to the left about to go into a Connex container burn. Look at the difference of the picture on the right. All you see is the firefighters going in through the eyes of the thermal imager. You don't see the big picture. Now, if I'm going to hit it home, here's a fire that we had in our area. There's the firefighter going up to make vertical ventilation. He's the first one up, one coming behind, captain's down at the bottom. That's a limited field of view, about 37 degrees. If I'm the incident commander and I'm conducting the 360 and I'm establishing command, I need to ensure that I'm far enough back to see the big picture. It's the same thing with your camera. You need to find a balance of the optimal range, which is the effective range that it works to see the best picture, which takes training. So here I step back a little bit. Now I see the two firefighters on the roof. I can actually see a little bit of fire in the lower left-hand corner. And if I'm the incident commander, I'm trying to see two sides of this structure. Look at my picture now. Can you see those two firefighters on that roof line? What if that incident commander had a high resolution field of view camera that was able to see them? Would they be able to see the fire running underneath the roof, getting away from them? You know, if those firefighters are on the roof without a camera, it's more difficult to spot that vent hole. They can actually see the roof joist with the camera because they are obviously emitting heat signatures. So there's another example of how you can use your camera. That's seeing the big picture. I need to have a wide perspective. It's critical to be able to see that. So we talked about modes and how they can be, confusing. I've talked to different departments that have some cameras that have 5 and 6 functional modes. I asked them which one they're using on the fire ground. They said, oh, just whichever I feel like. No. Do you let your firefighters choose how they put their gear on the truck and what tools they carry and what hose line they're going to pull just based on how they feel like? No. It's based on your standard operating guidelines. It's based on the way you do business, the way your crew's managed. So if I am going to use one of these, I need to have a set mode that I use that camera in. Bullard's made it easy because if you use their camera, otherwise, besides the electronic thermal throttle, you turn the camera on, it's dark gray, white, yellow, orange, red, and then you have the low sensitivity mode and super red hot. There's no other extra buttons, bells, or whistles. There's nothing to get confused about. Very straightforward. The reason I call this mode confusion, here are 2 shots you're looking at. The one on the left is a firefighter moving down a hallway into a fire room. They don't know that that room is that hot without the camera. The one on the right is a fire exhausting out of a doorway and a window. Both of those shots are about the same temperature. Most people would look at it and indicate more temperature or more colors would be worse. We need to understand how to read what we call the color palette. Be able to look at the big picture and see where those colors are, what they indicate, and how that affects my decision making. So most cameras have 2 to 3 modes. In this case, the Bullard has really 2 temperature modes. It has that low sensitivity mode we talked about and a higher sensitivity mode. I need to be very aware when it switches to when you see that little EI show up, the low sensitivity mode, because that means I am at the upper range of my PPE. I'm at the upper range of where things start happening with extreme fire behavior. I need to be aware of that, and I need to be constantly monitoring it and trying to make that environment better and safer. Just like we talked about, the EI is the electronic integration. That means you see that in the upper left-hand corner, it indicates your sensitivity mode is low, and that range is between 300 and 1200 degrees, and you need to remember the range of your PPE. So that's a lot of information. Here's how we simplify it. Yellow, orange, red. That easy enough? 500 degrees, that's yellow, anything above. Orange, 800 degrees and above. Red, 1000 degrees and above. Look at the arrow at the bottom. Go, no go. That's where we make our decision. If it's 500 or above, if it's below 500, it's a go. If it's above, we don't go until we do something about it. It's not saying you don't go permanently. It's just you cool the environment. You change that environment so it doesn't be 800 or greater when you're down the hall without a hose line or with a hose line and not cooling at all. Orange is warning. Pay attention. We're at the upper end. Things are going to start happening here if we don't do something. Red is injury or death. Anybody have any questions before we talk about what that means on the interior attack mode? Anything? All right, so we get to right about the hour mark. We're going to take a break, okay? I don't want everybody to they need to get up and move around. So when we talk about temperature modes, you just heard me say there's a high sensitivity mode and a low sensitivity mode. And why that's important for us to understand is the guys overseas teach interior offensive and defensive, and they teach exterior offensive and defensive. Why that's important for you to know is if you look at these 2 pictures, the left picture is a outside exterior picture. Fire and smoke exhausting out of the doorway. It's less than 500 degrees. That's an offensive mode. Can move in, knock that out, move forward. The picture on the right is me and the crew inside the foyer area outside of a room that's flashing over. Understanding color palettes like we talked about is important because here firefighters would mistake saying black or gray is cool. Well, black and gray in this camera's mode in the lower sensitivity mode is over 500 degrees where I'm sitting taking that picture. If I moved into that room, which is 0 visibility, it just flashed over. That's over 1200 degrees at the 4-foot mark and hotter than that at the ceiling. If you told your guys to make a right-hand wall search in that room without a hose line, they would be critically injured or burned or worse doing it in that room because that's 0 visibility, no indications other than when their gear gets hot or the air bottle gets hot or they start to burn. That's an interior defensive mode. I need to do something about that before I try to enter that environment. There's a better shot of that. Keep in mind that's zero visibility. No, you can't see your hand in front of your face. That's why it's important to understand tactical TIC use and how it can benefit us, because the majority of the fires we're going to, whether you practice vertical ventilation, whether you do different vertical or ventilation techniques, when you arrive at them are vent limited, which means they're nasty, turbulent, black, grayish smoke. They're not getting enough air, and we have less than perfect or zero visibility. So quick numbers for food for thought. Human skin's destroyed at 160 degrees. So all the arguments you hear about steaming victims and burning them up because we use whatever type of nozzle we use or how you apply it, after 160, it doesn't matter. 447 degrees, your polycarbonate on your mask begins to melt, no matter what the new standard says. I've seen them personally go from standard room temperature to an immediate change of 800-900 degrees, and those masks shatter. Okay. 572 degrees, your gear starts to char. And then at 1100 degrees, that's your post flashover temperatures. This all can be found on the NIST website. This is not my information. This is people way smarter who come up with this. All right, have any of you ever had a camera that you said they threw the camera down because they said the whole thing whited out and it wasn't working? Anybody ever had that happen? That's called color palette saturation. What that means is your camera has a maximum temperature range. If you see that color bar on the right-hand side that goes from 200 to 1200, the max range of this particular shot is 1200 degrees. So when the majority of that color palette, that picture you're looking at, reaches that temperature, it will either be that one color all the way across, or it will white out, which means all the pixels in that shot are at that temperature and it's overwhelmed the sensor. That's not a time for me to throw the camera down. It's a time for me to move my focal point and readjust and cool that environment off. If you look at the bottom right-hand corner, you'll see a little tiny blackish area that says air intake from the door. Right, this is a shot from the room, like the wall side looking back towards the entry point. That fire in that room is flashing over. They shut the door to that room, did not enter it. And in 15 to 20 seconds, it went from that temperature, which is over 1,000 degrees, to 400 degrees and survivable temperatures at the floor without adding any water whatsoever. Now, why is that important to you? We like to say that we always search with a hose line, but I know that's not always the case. There's many departments that do primary searches and searches without hose lines. If I was searching an environment and I came upon this and I saw that with that camera and the crew's coming behind me, I was able to quickly identify there was nobody in that room. I could close that door, as John Norman says, locate, confine, extinguish, move forward, and not have to worry about that fire coming in and impending on my guys or the attack team behind them, and I can communicate that information to them where the fire room is. Or better yet, if I had an extinguisher, I could throw something in there and close the door. No different than you putting water underneath a pot and putting the lid on it and putting it out. So let's talk about resolution. How many of you know right now the resolution of your camera? Anybody? All right, how many would you go buy a cheap TV that you can't see really well and want to go watch the Super Bowl? Not many of us. So why would I buy a camera that has a low resolution and I can't see very well in a vent-limited, nasty, smoke-filled environment, and I'm trying to find something like a small child? I have a 6-year-old. You realize the NFPA 1801 standard, that the actual image clarity standard part of it is based on your ability to see a size of a small child's hand. Now, why did they do that? Because that's who we're looking for. Kids hide. I need to be able to see in an environment that nobody else can see in. If I have a better resolution camera, which we'll talk about here in a minute, not only will I be able to see that child's hand, I'll be able to see it from farther away. I'll be able to see smaller embers that could cause issues later. I can see fire and the actual temperature at an accurate level that people can't see. As you can see in this shot, I can see, and this is a conic container, I can see the actual ribs in the metal. I can see the thermal severity ahead of me, a 1200 degree environment. I can see the detail of their air pack. I mean, that's impressive to be able to see that. So let's talk about why that's important. Right now, the majority of the cameras on the market fall between two resolutions, 160 by 120 and and 320 by 240. They're getting a lot better, and you're going to see some dramatic changes in that in the next couple of years. But what that means to you is you're doing a directed search with your crew, and you come upon a room, and a standard bedroom on average is 12 by 12. I have a 160 by 120 resolution camera, and they told me that the kid is in the back right corner bedroom. I come to that doorway, tell my crew to go in after I scan the room. I have a 160 by 120 resolution camera. I can't see that child more than 7 feet away if all I can see is their hand. Now, I don't know about you, but I got a 6-year-old. If somebody tells me their 6-year-old's in the back bedroom, and I scan that room and I don't know that, and my guys do the search and they miss them, I don't want to live with that. I need to know better. So what that means is, I'm not saying you got to go out and buy a brand new camera. We don't all have that kind of money. The current camera I carry on my truck is that resolution, and we got a pretty healthy budget. We still haven't improved upon that. So if I know that, that means once my guys are 7 feet away, maybe I should shut the door behind me, move forward every 7 feet, and reassess, because that's my effective optimal range with that camera. But with the Bullard that most of you, or at least with Chris's department, if they have a T3 Max or greater, they have a 320 by 240 resolution, which means they can see that kid's hand from 15 feet away. Now I can see better. I can see that if that child's hidden in the closet or hiding under the bed, I can see things that a lot of people can't see. And there's some cameras out there right now that are 384 by 288 or greater, which I could see a victim from 20 feet away. And I hope I got your attention with that, because to me, that's what makes this all worthwhile, is we're here to make a difference in other people's lives and our own. So getting to the last part of the key attributes of the camera, the distance to spot ratio is one of the top 2 features of the camera that affect how it basically measures the temperature of the environment you're looking at. And if any of you, got kids, or you playing with a flashlight, at work, you can understand distance to spot ratio by doing this simple test. Take a flashlight, stand 2 feet away from the wall and point it at the wall, and then walk backwards. That camera or that light will get a bigger circle or make a larger circle. Now that circle or that light will be less intense the further you go away. It's the same thing with distance to spot ratio. What that means is your camera measures temperature really accurately in a certain range. So if I had a camera that said it had a 10-to-1 distance to spot ratio, that meant it measures a 12-inch circle from 10 feet away really accurately, wherever that little crosshair is, that focal point. If it's a camera that has one that's greater than that, say an 85-to-1, that's great, but you need to know what that is. Most of them won't tell you without talking to the manufacturer. Like, for example, they say with a Bullard, it's 3 foot to infinity. That's not accurate. You look at the resolution, you look at how they calculate the temperature, you would be able to figure out that a 320 by 240 resolution camera is approximately 15 feet, just like we talked about a minute ago. That's why it's important for you to know that. So a difficult word, but an important meaning. Emissivity, why is that important? All right, if I am doing a size up of a structure, how many of you got concrete burn buildings? You've been in concrete burn buildings, right? So if I'm doing a tactical 360, something we talk about, and I'm scanning the outside of that building, and the concrete's nice and smooth, that is what we call zero emissivity, or more like a mirror. So if the camera is pointed at that, it's going to be less accurate. Just like if you pointed at a window or a mirror, you'll see a reflection. But if I pointed at a rough substance or surface like a couch, brick wall, wood siding, that's closer to 1. So it goes from 0 to 1, just like specific gravity or vapor density, all that stuff is measured from 0 to 1, same type of measurement. But when we look at 0, it's a mirror type surface. If we look at 1, it's more like your gear or, our skin, wood siding, couches. That means it absorbs heat, emits heat, or radiates heat really well. If it's a 0, it reflects heat. It doesn't show a heat signature very well. If you want to get a good idea how this works, take one of your shiny pots you got at the fire station, put it on the stove, boil some water. When it gets really good and hot, point the camera at the pot. The pot will read whatever room temperature is because it reflects back. But if you touch that pot, I bet you get burned. Same principle if you're inside a house, you're scanning the room, all of a sudden you see a reflection. A lot of people would mistake that for a person, or they would mistake that hey, there's another firefighter there. No, it's me. And the reflection means, to me as a crew leader, I need to investigate that further, because there could be something behind it. Could be a stainless steel fridge, could be a bathroom glass shower door that somebody's hiding behind. It could be something that there's a heat signature behind it and I don't know. You need to be able to notice that. That's why emissivity matters, because emissivity and distance to spot ratio are the two key critical factors that that camera calculates that temperature based on. All right, we'll do a couple more slides and we're going to take a break. So let's learn what the camera won't do. False positives, reflections, so just what we talked about. What emissivity means is you're seeing a reflection, something that reflects energy really well, whether it's glass, whether it's a shiny surface. The camera will not see through that. And one of the greatest mistakes is in understanding thermal imaging camera is the fact that we interpret the image wrong. And a lot of times that's because we're looking at it and say, oh, it says it's 67 degrees. And I'm pointing at a reflective surface. No, whatever's behind you is 67 degrees, but that surface may be a lot harder. How many of you come in and somebody had a fire the night before and they didn't clean the truck, they didn't clean their air pack, they didn't clean the tools, and you got to go in and clean it? A blocked optic lens or the front of that camera, if it's dirty, just like me wearing glasses, if my glasses are filthy, it can make a difference of 200 degrees or more on what that camera reads. It will not interpret that data efficiently if that lens is blocked or clogged, or it's got a mixture of attic insulation and soot jammed up in it. The other thing is intrinsically safe. That's a big hazmat word, which basically means, am I carrying something into an environment that may cause a spark? The Bullard camera is not intrinsically safe. So if I carry that into a natural gas leak environment and the upper or lower explosive limits are just right, I'm carrying something that could cause an actual ignition source. Be aware of that. Also be aware that if I carry it into a IDLH environment of another kind, say I've got some kind of chemical leak or spill of some kind, and I clean everything up, I take it back and I put it on the charger in the station or in the truck, what do you think that thing does after it cools off? If it's not intrinsically safe, it's not sealed completely. Whatever environment it was just in, the stuff that got inside that camera is now going to start to off gas, just like they've proven that your turnout gear can off gas up to 36 to 72 hours after a fire. That's why we don't take bunker gear into the bedroom. Same thing with your TIC, is if it's not intrinsically safe and I take it into a bad environment and it's not properly cleaned and I put it back on a charger, one could create an ignition source. Two, whatever was in it's going to off gas and expose to my firefighters or the next shift. So keep that in mind. The biggest limitation is the incorrect interpretation, which is us. We tend to look at the image, think it means something, and it doesn't. And that can only be overcome by training and education. And then most cameras have an over temperature rating, which means it will protect itself from burning up, unlike us. So in this case, a Bullard camera will shut down at 500 degrees after the core temperature has been exposed to that for 8 minutes, or 300 degrees for 16 minutes. So what that means is it's 500 degrees inside an insulated, sealed up device. So what do you think the temperature is outside? Way above where we need to be without making a difference by cooling it off. All right, it's time for a little break. It's been right at an hour. Anybody have any questions before we take a break? I'm going to move this down.
No, I think I'm pretty good. I know a lot of this stuff we demo in the station that is pretty easy to do, especially distance to spot ratio. I just turn on my oven, let them look at the burner. They get a good idea what the color palette is, and we just move that a little bit off the burner, and you can actually see that temperature drop and what the range is of your TIC. And I'll fill up the sink and just have them put their hand in it, and you can see that. And then, of course, mirrors or reflections. So it's really easy to do some in-house training, for free. So and it only takes a couple minutes. We actually do hose and nozzle selection in a Teflon pan with a spray bottle too, so you can see the pan cool and what it does when it's that hot. So pretty easy stuff. Yeah, thank you. How long a break do you want to take, Andy?
Just 5 minutes, whatever you guys need. Run, get a drink, go to the bathroom, that kind of thing, and then we'll get started again if you guys good.
Perfect.
Anybody else got any questions? All right, see you in 5 minutes. I'll run the timer. see the mute button on this. There it is.
Hey, Scott, thanks for coming, buddy. I know your mic's not working. It's good to see you.
Hey, can you hear me now?
Oh, yeah, I can hear you. Yep.
Yeah, I don't know. I had to switch computers here.
Good deal. Andy's recording this, so he's going to send it to me on a thumb drive. This, is part of his presentation at San Diego, the Firehouse Conference. So he didn't want to give it up and put it public right away. But I'm sure he'll let us get that out eventually, and certainly share it with our department. So that'd be good.
Yeah, it's good stuff. I've heard most of it. I don't know, whatever reason, my speakers on my mic just started going off on my computer. So then I switched the headset, and then it went off. So I don't know. I'm gonna try and restart my computer and see if that does it.
Sounds good. So I will. I'll catch up with you, and then I'll give you a copy. I've got a copy of the presentation, just not him speaking about it. So whatever you need, let me know.
Okay.
And a lot of this is in our original one, the very first one of these we did.
Right.
But I figure Andy could present it much better than I can. So.
Well, you know what it is. It's one of those things, you can see it 3 times and you learn something new every time. So.
Yeah, for sure.
Good review, but then I've already picked up some stuff. I've been trying to keep some notes over here to the side. Some stuff that I hadn't even thought about, even on our old cameras. And our cameras are so outdated now that we're in the process of, we just got done with getting new extrication equipment. And I think the next thing now is going to be TICs. We got monitors, then we got SCBAs, now we got extrication, and we've got new trucks that we got to get. And my suggestion was to get a new TIC with each truck.
Great idea.
Kind of roll that into and that way we can we're upgrading trucks, we can upgrade our TICs at the same time.
These are really good. If you're getting new trucks too, I'm just doing a presentation to switch some ladders and switch some nozzles around. And it looks like it's going to save us almost $3,000 a pumper. So, wow. And through attrition, I think I added up to almost $53,000 by getting rid of a couple outdated pieces and updating them and making us more efficient. So I'll give you that.
Okay.
And my friend Scott.
I just saw something on fire engineering that another presentation coming up about gated Ys and setting your trucks up for success or something. I couldn't recall who the speaker was. I just noticed a little side note there, so I was kind of interested to see what he's going to say.
Probably Dennis Laguerre, the old Oakland captain. I was just talking to Andy about him as well. So I got a cute video I want to show you of Blake, my 3-year-old. Andy, this is my friend Scott Munsterman. He's a neighboring battalion safety officer. He's basically him and his chief are my closest battalion, even though they're from a different city. We do what we call automatic aid. It's not mutual aid. So it's the closest unit regardless, set up on global positioning. So we're all on the dispatch system, so he'll get dispatched automatically with my unit. And being that he's from a different city, he's still the closest, so we work pretty tight together. So Scott is really the reason why I started doing these hangouts. He kind of said, "Hey, have you seen this on fire engineering?" And I said, "No, I haven't." And I looked at it and I said, "Hey, why can't we do that?" So he's pretty proactive in his department as well. So
sounds great, my friend. You guys ready to start back?
I think so. Everybody ready?
Yep.
Let's see if I can get this screen back up. Can y'all see the slide again?
Yep, the glass example.
Yes, sir. I'm just trying to get it up on my screen here. I can see it on one of the other ones. Give me 1 second here. There we go. That worked. It's not working now. You guys hear me okay? Everybody hear me okay?
Mm-hmm.
All right. See the
Yes.
glass example slide, correct?
Yes.
All right. So what we're talking about now is we're under the what it won't do. So if you see the firefighter on the right, you see his head above and shoulders above the glass, and you see his shoulders below. Do you see that at all in that thermal imaging shot?
Yes.
Yeah. So you can't see anything below the glass line. What we're talking about now is understanding what we said earlier about emissivity. Emissivity meaning that this surface reflects energy. Well, your camera works on picking up IR, infrared energy. So even though that firefighter is 98.6 degrees or hotter, his energy is not transmitting through the glass. Now, the misnomer is that you can't see through glass at all with a thermal imaging camera. You will be able to pick up heat signatures and different cues and clues, and we'll talk about that here in a little bit. So understand that glass prevents certain things, but there's ways you can overcome that. All right. All right. So we talked about keeping the camera clean. Look at the picture on the left of the optic lens, which is the front part, how nasty that is. That's an ISG XLR camera. It's got 100,000 pixels, which is great resolution. But look at the difference when you got the lens. Big difference. So I can see better. We're going to talk about how you maintain that when you're in the environment as well. All right, so how do I overcome that? Here's a picture from Fire Behavior University last year. You're looking at the end of a Connex container where they framed in a wall and a window. Now, if I was just to look at the spot temperature, what we talked about earlier, the focal point, it says it's only 60 degrees. So that's why we need to learn to read the entire color palette, right? But if I looked at the top half of that window frame, I see this nice white milk mustache signature. So glass, I can't necessarily see through it, but glass has a feature called transmissivity, which means it transmits energy based on what type of glass it is, whether it's energy efficient or whatnot. But getting past all that technical jargon, what are windows made of besides glass? They're made of wood, vinyl, metal, all that emits energy. So if it gets hot and there's something hot behind it, I will see a thermal clue or cue, as you can see here. So why that's important is that inside that room right now is a flashing over room. It's 1,000 degrees. But if I just read it by the spot temp, I would say it's only 60 degrees. So if I'm doing my 360 and I see that and I've got very little smoke conditions, I can say, well, that's probably where my room of origin is, or I've got a fire going on at least in that room. If I take that window out, I'm going to have significant exhaust and fire and lots of nasty stuff coming out. It's a lot hotter than 60 degrees. Is that good to know before I do a vent enter search? Better believe it is. All right, so let's talk about application. How do I make all this work? That's what firefighters are about, right? I need to know why this works, how it works. So before I can do any of this, we got to overcome the biggest limitation, which is, I've taught this class numerous times, and the biggest limitation I've seen is the camera stays on the truck. All right, it doesn't come off the truck, and when it does, it's like for search and overhaul only, and then it's like a second hand or afterthought. So your TIC needs to become part of your PPE. And I'm not going to tell you how to carry it. That's a personal preference, but I will tell you what's worked for me and what's not worked for me. The reason I got that little red arrow that says secure by that standard little retractable strap that they sell, that they give everybody, it's a little 99-cent deal that they give even hospital employees for their name tags. That little clip is a tension clip, which if you start crawling and you bump into anything, that camera will be how many ever feet behind you before you realize it. That needs to be secure wherever it's connected to you. I don't care how you do it. It's up to you. Make sure your connection point, whether you carry it with webbing strap, seat belt strap, however you carry it, make sure it's secure, it stays with you, and that you can actually grab it with a gloved hand, lift it up, and view whatever you're going to look at far enough away from you that you can actually do that comfortably. It's not jammed up under your seat belt straps or your shoulder straps or anything like that. And that only comes from train, getting used to it. And it has to become part of your daily regime. I carry mine on medical calls, car accidents, you name it, because it's a tool, and I'm the crew leader. I'm supposed to be responsible for them, so I need that information. So we got to look at our behavior versus the fire behavior and how it influences that. So if you've been in a nasty smoke-filled environment, you wipe your mask, you get that stuff off so you can see. The same principle occurs with your TIC. You need to wipe that lens so you can see. So every time you wipe your mask, just go ahead and wipe the front of that optic lens so it can see better. Any of you have been taught a 6-sided scan when you've been using thermal imaging cameras? Okay. I simplified a little bit. Basically, you're going to look up. The first scans for us, I'm looking up because where is all the heat? Above me, typically. So I'm going to look up, and I'm looking for that thermal signature, and I'm also looking for, despite what the naysayers say, you can see structural integrity loss. I can see roof trusses failing. I can identify gusset plates, laminated beams, lots of things that you wouldn't normally be able to. And I can see if any of that has failed. I can see fire over my head. So I'm looking up first, then I'm looking forward. That's where I'm going, where my crew's going, more importantly, because if I'm doing this right, I'm the third person back or fourth person back, and I'm keeping a tactical perspective, being able to see them, see the big picture like we talked about. So I'm seeing where they're going, what that environment looks like, and I'm looking at their gear. How many of you watched thermal imaging videos and seen the burn coaches coming in and out, and their contact points at their shoulders and their knees are all yellow and orange? What we don't realize is, as if you're a live burn instructor or whatnot, going in and out, your gear is getting superheated. If something happens, the students are not going to be burned first. You will be, because your gear is already saturated. If you're the guy or girl that's third person back with the TIC, they're taking the brunt of the thermal assault. You need to look at their gear and see if they're getting overheated, and you need to be cooling the environment and making sure they're not getting to the point where they're going to get burned either. And then I look behind us. And why do you look behind you is arson fire, multiple points of ignition. How many YouTube videos have we watched where people are breaking windows out behind the fire crews, changing the fire's direction of travel, all those things? I need to look behind me. Things could change. Things could get worse. I'm supposed to be watching out for them. I need to watch out for any unseen hazards or anything that may happen in that area. You need to avoid task tunnel fixation or vision, which means don't hold it up your face and hold it there. Do your scan, put it down, cool the environment, move forward, do it again. But don't hold that thing up straight to your face and take off and just be blind with that, because what happens is you end up leaving your guys behind. There's been documented cases of crew leaders who've taken off inside of a building with a thermal imaging camera, and they can see just fine, and their crews behind them lost. They end up calling a mayday because the crew leader ran off and left them. They couldn't see. Yeah. So applications, tactical 360, what that is. Access, go, no-go decision-making. Talk about conditioning or cooling as we move forward, or condition as we transition. How you maintain a tactical perspective with that TIC. and you need to monitor and communicate what you see to your crew and the incident commander, and how it can enhance your search ops or enhance search methodology. You can also use it for some of these other ones. We're not going to address these as much, but you do pre-planning, you can do thermal pre-planning. You take your camera and look at exhaust points in the building, what it looks like normally. So when you show up at 3 o'clock in the morning, you can say, that ain't right. That door's hot now, or that exhaust point for that vent fan has got 300 degrees coming out of it. I can use it for nuisance fire alarms or odor of smoke and electrical. I can go to the circuit breakers and look for overheated circuit breakers and go ahead and go right to the source of the problem. Motor vehicle accidents, I've used it on more times than I can count. I can tell whether somebody was sitting in the seat because they leave what they call thermal latency, or basically a butt print. If they say, well, I wasn't driving, there's a guy sitting there in the driver's seat, and I've been in the passenger seat the whole time. Well, if I look in the driver's seat and there's a heat signature in that seat, then I can tell somebody was there, whether they're telling the truth or not. We pull up on motor vehicle accidents. Typically, I hand the camera to my driver and tell him or her to make a lap on the perimeter and look for anybody who's ejected, because I can't see at night. You can use them for hazardous material incidents, depending on whether they're intrinsically safe or not. You can identify where leaks are, and you can use them for missing persons. So let's talk about our tactical 360. You're looking at 3 perspectives: tactically, which we know how to do; thermally, which we're learning how to do; and 3-dimensionally, which is the unseen hazards, the things we don't often think about that usually end up injuring or killing us. So that's tactically, thermally, and 3-dimensionally. Here's 2 perspectives right here. Same house. One of them you see fire exhausting out of the window. The other you see it from the thermal perspective. You're getting more information, and you're also looking at the first shot. They're too close. All they see is the fire coming out of the window. The second shot, they're far enough back. The field of view is big enough that I can see the exhaust coming out of the window. I can see whether or not it's spreading up into that attic. I can see 2 sides. I can also see, if you look at the double windows on the front, I can see some white or smoke storage behind that glass, which means that room has some significant heat in it. So how do you do a 360 normally? You do your typical walk around. You're looking for your basic indicators such as building construction, basements, any unseen hazards. I'm looking for signs of fire severity, where it is. I'm reading the smoke, volume, velocity, density, color. In my case, we read the neutral plane and look at it through the camera. I'm looking for all kind of different variables. But when I'm doing it with the camera, I'm looking for all that, and I'm also diagnosing hot spots, where the fire is. I'm looking at cold spots, which we'll talk about in a minute, why that's important. I'm looking at where the air is being drawn into the fire, which is a cold spot. I'm looking at signatures on windows. I'm looking for signs of any victims. All those things I'm looking at, and I can identify and manage the flow path while I'm doing it. So tactically, we know we look at a burning structure. I got a brick ranch, story and a half with a basement. Lower arrow shows me the basement. There's a propane tank in the backyard. I got a bonus room on fire upstairs. I've got smoke exhausting out of the B-side window and smoke exhausting out of a vent, which means it's probably traveling all the way across that upper floor. So I've got a good perspective right there as I'm walking up. So that's something I got to think about. But when I'm doing this, I have to have those determining factors, those key attributes. How far away am I, the field of view, what mode the camera's in, the color palette, resolution, distance spot ratio, and the emissivity. When I look at this building, it has a closer to 1 emissivity value, which means it's going to absorb or emit or radiate heat well because it's brick. So I might be able to see a heat signature. I might be able to see it through the roof. Distance to spot ratio, I'm going to stay within the effective range. The resolution of the camera, I'm going to be within 15 feet. I'm going to read the color palette and see what I got. Here's your commercial structure. It's like a Rite Aid building. This is taken with that same type of camera, the Bullard, and it's in the grayscale mode. How does that tick affect your size up? Now, if you knowing what you know, chime in at this point, because we're going to start. This is where you start to get really engaged in this, I hope, is where we start to talk about what we can see, what we can't see. I've got one slide with no information on it, and then we got one where we've got some key points. So what can you see here as an incident commander? What would you glean from this shot looking at it thermally? Anybody?
We've got a well-involved fire, and it looks like a storefront that's extending to the left of the Bravo side, if this is the Alpha side.
Very good. Anybody else? So we've identified the fire's location and severity. right off the bat. So it's in grayscale, so white means it's hotter. So I can see some exhaust. I can see a heat signature across the roof line. I can see a roof ladder going up. I can see look at the front door. What do you see at the top half and what do you see at the bottom half? Is it hotter at the top of that door than it is at the bottom?
Yeah, identify a flow path there.
There you go. All right, let's look at what we learned. First, we know that the fire is significant in the front portion of the building. We've got white, which is a signature of heat being transmitted through that glass and through that door, which is open. I see air going in the bottom of the door, which means I got a bidirectional flow, which is point number one. Point number two, I got a hot exhaust above that, which is not directly connected to it, which means I've got fire travel somewhere through that building coming out that side, maybe a exhaust or a window there. I look at the rooftop, the little hip roof, little portion there, and across the top, it looks like the fire is going up and traveling to the left, as point 4 says potential fire spread. I can see heat signatures along that roof line. So if I'm a truck company, I'm doing typical truck company work at a commercial structure, and I'm assigned to go open up this structure. If I opened up the door and windows where arrow number 4 is, do you think I'm going to change that fire's growth significantly?
Absolutely.
So maybe I should unlock the door and then close the door back, put some type of strap on it so somebody can get out but not leave the door open and not take the glass. My father says taking glass should be a command decision that everybody communicates, and command should say take the glass on Bravo side, C side, whatever it is, and everybody should know that that's occurring. It should not be a random freelancing act. It's ventilation, not vandalism. It has an effect, and we need to be very careful how we do that. If you don't believe me, spend a few hours drinking your favorite beverage and watch YouTube, and you'll see that that can go bad really quickly. So, severity and location of the fire. You saw the severity and location of the fire in that commercial structure. Here we're at the A side. We're just looking at the front door. All right. There's an acronym that my father teaches called Now, Next, Future, Past, which is a good incident commander, would you agree, has been taught to think 2 steps ahead of the fire. So I'm always thinking, is it getting better? Is it getting worse? If I do this set thing of decisions I've decided upon, where's it going to go? You know, if it gets ahead of me, what am I going to do? Do I have enough resources to handle it? I don't know if any of y'all taken blue card, but they have the phrase called on deck. It means I've got somebody ready within close proximity of that assignment that can move in and take that person's place really quickly. I need to have another set of decisions in my mind on deck, ready to go if this does not go the way I plan it to. So that's now and next. And then the future of what this could do in that case, and then my past experiences with that. That's your decision model there. So where's the fire right now? Where's it going next? What's the future going to look like based on my decisions and what my past experiences tell me? So if I look at that with a thermal imaging camera, I can see a bidirectional flow. I can see the temperature of that smoke or that exhaust. And another thing we need to point out too is thermal imagers read infrared heated energy off of surfaces, not gas temperature. So for somebody to say, well, it was the smoke temperature was whatever, that's not completely accurate. You're reading the surface temperature around that smoke. And in this case, this was my eye opener. The temperature of that exhaust around that door frame is 1100 degrees, where I would normally stick my head in, no problem at all without a hose line, until my epiphany. So I can identify the flow path. What's the bottom half of that door there? What is that? Anybody?
The air track or the air train, whatever you want to call it.
That's your air inlet or intake of your flow path, right? You have an inlet on the bottom and an exhaust on the top. So if I'm doing my tactical 360, I'm the guy who's first there. I come up and I see the door open, and Chris and I talked about this. He come up with this one, so I give him credit for it. I quickly take my camera, scan the door from the outside. I can lay down in that air track down at the bottom and scan it and get me a quick feel for the layout, locate where the fire is, and where do we find victims typically? Windows and doors, right? Because they're trying to get out. So if somebody's right inside that door, don't you want to check really quick before I finish my 360? So, and I can see them with a camera pretty well. So I look really quick and then I can shut the door and continue on my walk around. All right, neutral plane height. Everybody familiar with that term? You heard that term? Why it's important is it's indicative of fire growth. It's like a gauge. It's incipient, free burning, fully developed, decay. Well, when you see the neutral plane's height tells you the proximity of the fire and how far it has grown at that point. In this case, it's 50% of that opening. How fast do you think it's going to go from 50% of that opening to the floor and become a full exhaust? Anybody? If I don't control the air of that fire and I'm doing my 360, guys are pulling hose lines, everything up, how fast is that going to change?
Very fast.
Depending on the size of the structure and the contents, very quickly, because what do we know about today's fires versus legacy fires is that they grow exponentially quicker, not that they're hotter, but the heat release rates are greater. So the fire progresses faster, flashovers happen more quickly. So if I left that door open and my crew made a push down that hallway to the fire room and I didn't control the air to it, do you think that it's probably going to progress and ignite right where that neutral plane height is? And then I'm going to turn around and try to crawl back through flames. That's why we need to understand this. So I'm doing my walk around and I scan the garage and I see this. What do you see here? This is a Bullard camera shot, by the way. You're the incident commander. What do you see?
Looks like a water heater, possibly. It's gas fed.
What's that?
Those are acetylene tanks.
Yes, they are. Very good. So I have acetylene tanks with a door possibly behind it. I've got, what do we talk about? Thermal severity. Other red means what with this camera? What temperature?
1,200 degrees.
Yep, we're over 1,000 over there behind the car. And I got a couple of acetylene tanks. I've got, look at the yellow on the ceiling. Remember when I told you could see structural integrity loss? What size is your sheetrock typically sold in?
4x8.
Look up there in the upper left-hand corner with me. Let me get you a zoom here. Right there. What do you see an outline of?
The nails, the screws.
Yes, you do. So how quickly do you think that's going to fail and fall on your head?
Probably pretty quick.
So do I want to put me in there first, or I want to put a stream in there first?
It looks like your relief valves are going off on those tanks too.
Possible. So, you know, we have a lot of fires today. I'm sure y'all get the same ones as we do. You get exterior fires going interior, whether they're sprinkled buildings or not. It's happening a lot. You get car fires in garages that extend into the house. Fires naturally go up. So this fire is trying to break through the attic, which it's about to do. I've got an extenuating 3-dimensional factor, which is I've got somebody who's a welder or whatnot, got them a little acetylene tank set up or whatnot. They may be home oxygen cylinders. I don't know. That's critical variables or factors, exceptions that need to be communicated to those crews. They don't need to just charge right in there and then these tanks explode. And then I don't know if you watched the Phoenix video from years ago where they're cutting on that tank and it blows up.
Ricky Pierce. Andy, you brought up a good point, and I'll just jump in real quick. And I know you're going to get into it when we talk about masking and some other limitations, but to teach our guys to identify shapes and not necessarily just look at hot or cold is equally as important. Because like I think it was Mike or Scott that answered that. He identified that as welding equipment or some type of tanks right away. It's the same thing with looking for victims. If we train ourselves, like you said, with masking or a child under covers or blankets, you know, if you train yourself to look for shapes like that and identify it, common things will help you be more efficient or proficient with your tactical thermal imaging. So that was a good call, Mike.
Yeah, that's why I want to engage the discussion. Thank you, Chris, is that you guys will bring out stuff that, you know, I may not talk about. And I want you have a diverse set of experiences here. And what we want to do is engage and discuss them here so you can learn from them. The other side of that, what Chris is talking about, we'll talk about later in the enhanced search methodology, is how many of y'all were taught when you did smoke training or thermal imaging training for search that you're looking for victims that show up as white hot in that environment? Anybody? Because what happens is we get used to searching for mannequins or victims in cold smoke. They show up as white hot. And we're in a superheated environment. Is a 98.6 degree victim going to show up as white hot? No, they are not. Mute for me, please. You're going to see, like somebody pointed out a minute ago, they identified the shape of those cylinders. They're the darker portion here, but they're the more dangerous portion. So don't always associate color with the danger as much as I need to be able to identify shapes, read the palette, and see what I've got. Just like there's a car here, there's cylinders here. I can see, you know, it looks like some type of cabinetry in the back. I can see the outline of the sheetrock and where the fire's going. All that's good information that you didn't have before. Because right now, that fire's taken where you don't, when you look from the outside, zero visibility once you got inside that garage doorway. So we talked about now, next, future, past. Here's a good example. That same shot you saw a minute ago, this one right, whoops, this one right here, is this when I step back and look at it. You see the burn building? All right, so I got a bidirectional flow from the A side door. What about the D side? What do you see coming out that window? Is that an intake or is that an exhaust? Anybody?
An exhaust.
I think it's exhaust.
Okay, so we talked about identifying the access right here, making a quick look, seeing what we got, checking for victims. I close the door. I start my walk around. I don't know about you, but I go A, B, C, D, or 1, 2, 3, 4, however you signify the size of the structure in your area. But I walk Alpha, Bravo, Charlie, Delta typically. So I'm walking around, and by the time I get back around to the D side, since I've shut that front door, what do you think happens to that window now that I shut that front door?
It's going to turn into a bidirectional flow.
That's exactly right. So if I'm in a limited staffing department with very few individuals on scene, or I'm looking to kill that extreme fire behavior really quickly, is that an opportunity for me to do a transitional attack, knowing that I just limited that fire spread by shutting the door? It's a quick way of doing that. And the reason the thermal imaging shot's put beside it is the inside of that room is flashed over. And you can see in the ISG camera shot here that there are 1200 and above temperatures in that room. So if I don't control that air and I don't have a hose line in place, that fire's just going to grow. So fire grows from compartment to compartment. So that room's flashed over, it moves to the next room and begins to get those gases and ignite those gases. So I already flashed over in the AD corner, and I've got a lot of air coming out the A side. Where do you think it's going to go? Where the air is, right? Put your hand in front of your face, try to breathe, you're going to turn away to try to breathe. I shut that door, it's going to turn away and try to breathe wherever it can get air. It's a smaller space. It limits the ventilation or limits the growth of the fire, it decays it. As my father likes to say, we got to decay the fire, not grow the fire. We're venting for the fire victims typically. So here's you another shot. I'm doing my tactical 360. This is a hip roof on a brick ranch home. Tell me what kind of information you can see here as the incident commander as you're doing your size up. Jump in, anybody. This is a FLIR K50 shot, just so you know what kind of camera we're dealing with. We'll go through different ones, but.
And you can see a lot in that picture. You can see, you know, probably where it started, what the flow path is, what it's doing in the next rooms, and where it's spreading. And clearly through the roof. And I mean, just looking at that image, it looks like a defensive fire to me. So.
Anybody else? Those are all good points, Chris.
Yep. Depending on what kind of structure you're involved with, try and guess. It looks like it might be brick. You might have a room that you can still do a vent end or search in real quick.
Which one would you choose?
That far left.
Yeah.
All right. So judging by the amount of color you see in that shot, knowing what we know about the color palette, and this one works off the same basic color palette, red being 1200 degrees. How much of that structure is over 1000 degrees?
The majority of it.
Would you say over 50%?
Yeah.
Mm-hmm.
Which direction do you think it's going if I take the window to that room and don't isolate that door? That you
Right at
you.
Come right to you.
All right, so if I was going to do a vent enter search to that room and I wanted to control it better, what would be against your tactical decision making if I went to the opposite end where that big nice heat signature is on that big window, and I took that window out and let that develop into an intake exhaust, quickly made entry to that other window you're talking about on the other end, isolated that flow path, made that search, and got out.
And that's a great idea. I think you can use the flow path to your advantage. Another thing that came to mind, and I know a lot of people aren't familiar with it, is what I learned at KTF with that smoke curtain, replacing that window with the curtain before you take it. That way you don't have a flow path change, and VEIS that.
If any of you have access to that, it's a great device. Most departments don't, but as Chris pointed out, we use it at KTF and on all the tests. Basically, you're creating a door over the window. You take the window, then the curtain comes down and it does not add to the fire's growth. So I could enter that, go in, close the door, and never have to worry about that fire coming to me unless I had another window fail in another direction. So those are all points you can consider, but let's look at it from a tactical perspective. I'm the incident commander. I'm looking at it now. I say, okay, I got a brick structure, a hip roof, which are typically stronger roofs, probably 1950s, 1960s construction. I've got 1, 2, 3 windows of 1,000 degrees or higher. I've got self-vented, possible roof structural failure of a, probably dimensional lumber. And I see the middle smallest window, which could be a bathroom or a kitchen based on reading the building. But above that window, I see yellow progressing upwards. So that is a ventilation or thermal bridge right there. It's actually traveling up and out there where it's not traveling up and out of those other windows. So the typical fire department mantra would be taking windows. If I took those windows out right there, that fire would grow exponentially. So I want to make the fire not grow. So most departments are working off limited staffing. If you're blessed to have staffing, good for you. But in this case, a quick knockdown with a large gallons per minute device from the exterior would work. Doing what we talked about, if we had a life hazard, we wanted to isolate it, that would work. But you need to communicate this information to crews that say, I've got a structure that's more than likely going to collapse fairly quickly. And if this is lightweight construction, we understand that it can fail anywhere between 6 and 13 minutes. And by looking at that, I would know that it is at the point that the roof is going to fail if it hasn't already. Has anybody got anything they'd like to add to that?
Hey, Andy, I got a question.
Shoot.
So it looks to me like those windows that are all red, that would be like exhaust ports or something, because the one second to the left has windows up above it that aren't broken.
Mm-hmm.
How come those are red? And if you're saying they're not broken, that's what I'm trying to figure out.
Remember we were talking about glass earlier, how it can show heat energy.
Uh-huh.
Okay, if it's broken, and I'm reading the color palette, what would be above that window coming out?
Like you said, maybe the yellow or orange.
All right, so if I remember my color palette and how it transitioned, if I start a campfire and the base of the fire is 1,000 degrees and 20 feet above it's going to be cooler, right? So
yeah.
If the window has not failed, I'm going to have a lot of heat wherever that growth is, and then I'm going to have a heat signature in the glass. But where the window has failed, if you see that blue arrow, you can see yellow, which is in this case anywhere from 600 to 800 degrees, where it's transmitting out. There's some type of failure there. If being a smart incident commander, I would know that you would look at this and say these windows will fail shortly. These are probably older windows. They hold up better because these could be metal casing. We don't know. But let's look at it from this perspective. We know that little button in the upper left-hand corner, if it was a bullet, it said EI, would mean it was in low sensitivity. Most cameras that are NFPA certified will have a triangle like this, which means low sensitivity, which means it's in the upper range of the camera. Okay, the color palette, yellow, orange, red, it's maxed out. How much of that shot we said is red? So the majority of that structure is 1,000 degrees or hotter. We need to do something about that to make it better for us and for the victim. The fire is progressing to the left if I don't correct, mitigate, or change that depending on what I have available to me, whether it's, as Chris said, a curtain, whether I change the flow path, and I need to look at the maximum temperature of this camera. This camera is almost maxed out. If I get inside that environment with that camera, my likelihood of being able to see is probably pretty slim because it's going to max out. It's going to saturate. That's a large amount of fire in a smaller structure, probably 1,500 square feet. Anybody have any questions on that? About what we talked about with glass and being able to read it?
This is a great discussion for even what we're hitting it hard from the art.
Yes, sir.
About taking that far right window,
Mm-hmm.
the two little windows just to the right of the yellow window,
Mm-hmm.
hitting that with the hose string,
Mm-hmm.
and helping maybe push some of that exhaust to the right. Now, I'm with you 100%. Now, out here, this would be a defensive fire for us.
It depends on your staffing. I agree. Yeah. And your resources.
But you know, with this hitting it hard from the yard and all this, the new literature, it'd be interesting to see what would happen on this. Not necessarily this is self-vented through the roof, but take that self-vented roof out and see what this would do. Would be very interesting.
I agree. If you didn't have the self-vented roof, I would talk about what you're talking about. But judging by the amount of fire coming through that roof, if I showed up in a combination or limited staffing department and I have a high flow deck gun and a patent water support source, I got a pretty big hole to put that through. You know, and let's face it, out of 1.4 million firefighters, 1 million of them are combination and volunteer. We don't all operate off FDNY or paid municipal tactics. We're showing up with 2 to 7 people on average. What can you do with your staffing is up to you. But yeah, I'm not going to tell you what to do. It's just you need to make those informed decisions based on the information you got, your staffing, your resources, and, you know, have somebody on deck. Have your 2 in, 2 out. You can't do that. You know, you have to make that call and then justify it later. As my boss always says, you got to be able to explain it. Yes, please go ahead.
Oh, I'm sorry. I didn't want to interrupt you.
No.
You know, at the beginning of the year, we had a couple Phoenix firefighters burned. One pretty bad, 2nd-degree burns, 30% of his body. And his captain noted that his TIC whited out when he walked in there. He didn't know what that meant. And for some of you guys that came in late, you know, that's a true sign of flashover, and you need to get out or, you know, change those conditions rapidly. And when I say rapidly, I mean get out because it's going to change fast. We don't do, it's not common, I can't say we don't do, a lot of VEIS here. So for the Arizona guys that are online with me right now and that weren't at Tactics on Tap, I know we discussed vent, enter, isolate, search. And if you want some of that, I'll be glad to give it to you. I know Ladder 4 just did it successfully on A shift, and it was something that we had talked about before, so I'm really glad they did that. But it's a really common search technique in other areas. So if you guys want more information on that, hit me up after, and I'll be glad to send you that presentation. So, and if you want to talk more about flow path, we can certainly do that too. So I'll let Andy get started again. Sorry, Andy.
Oh, that's great. And also we have some footage from KTF and South Carolina Fire Academy where we did vent, enter, isolate, search under live fire conditions, with the fire below us extending up, which is, my knowledge, one of the first ones done that was with thermocouplers and cameras, if you want access to that as well. All right, and let's look at another example. Go ahead. I'm sorry.
I'm sorry to interrupt. Can you go back a couple slides to the strip mall or the drugstore front?
Sure. Yeah, it's like a Rite Aid.
Yeah.
Yes.
This one right here, something I wanted to just throw out there too that I was thinking about, and this is more of me as a safety officer walking around with my TIC from the outside. I got a ladder about halfway where this flow path is going. There is a good chance that my ladder crew might not be able to get back down, depending on how this opens up. So for our guys,
by the way, you're the first one to catch that, so bravo for that.
So for our guys that catch or that do the RIC crews, now our RIC crews, I try to give them a second TIC camera whenever possible. This would be a good thing for our RIC crews to even look at and start identifying and communicate back to command that, hey, we either need to move ladder crews down, move our second means or get second means of egress if we isn't up already, but this one might not be able to be utilized.
Yeah, we don't crawl down chimneys, right? So we don't want to create a barbecue grill for them to crawl back down and be burned up. So a quick ladder roll would fix that problem. You know, you being the safety officer, you know, small ladder like that, I could roll it 3 times to the left, communicate that to them and say, okay, by the way, I'm seeing fire heat signatures on the roof line moving from the right to the left at a significant rate. You need to do what you need to do and get off now. And being the safety officer, that's a good call. So bravo, good job. That's what we need more of, is people making more informed decisions. So, all right, so let's look at, this is side A. You're the incident commander. You got crews about to make entry into this fire. This is a standard fire attack. No enhanced fire behavior tactics, as we like to talk about. Chris was talking about earlier about training yourself to look for shapes. You've done thermal imaging training where you're searching for a victim. Anybody notice what color the firefighter is in this picture before we get started? Can you see him?
Cooler.
All right. So There it is right there. So if I'm searching for a downed firefighter or a victim, are they going to show up white hot in that environment? Nope. They're going to be the darkest, coldest thing in the room, unless they're getting heated up or burned. So if I'm searching in a 1200 degree room, 800 degree room, or I'm searching for whatever the temperature of that room is, and you scan the room and people immediately start looking at the hottest area. This is why cold spots are important, because cold spots are typically where your victim is going to be or be your victim. You see a bed and you got a dark spot in a corner, you need to have your crew search that. You need to scan slowly and they need to search fast. So that's a quick little tidbit there, but let's look at it. We can see neutral plane, right? Looking at the front door, right? 50% of the opening, yellow, orange, red. Got significant fire growth, fire exhausting out of the window, which by the way, that in the actual optical picture, that's just black smoke. All right. Notice the cold spot. So that's the air inlet, the front door. I can look at the fire location. And it's also moving to the right. So as an incident commander, I'm looking at this. What information can I quickly gain? And what can I do really quickly to make a difference in this environment just by making that assessment with the camera?
Cool.
You can figure out from that picture, you can definitely figure out the neutral plane. That's very obvious. You can figure out where your exhaust is, probably where your fire is spreading to there. If you had a little better shot of that doorway, I'm guessing depending on your resolution in your camera, you can identify that air train for the seat of the fire and whatever's below it as far as the pyrolysis that's going to occur or anything like that. So again, there's quite a bit you can tell and where you want your initial hose line more than likely to cool down that environment.
All right, so I want to shut that. I want to make the fire decay, I want to make the fire go away. So learning what I've learned about the camera so far, about focals, the crosshairs with the focal point, do you think that fire is hotter than 122 degrees?
Yes.
Why do you think it says 122 degrees right there?
It's pointed at the bottom.
That's right. The 12-inch circle or whatever spot of this camera is that's all it's reading. So when you move the camera around, it will change the severity of the picture and the clarity of therefore. So if I'm scanning high and it's hot, I get lesser resolution. I scan medium height, it gets cooler, or scan a colder spot, the camera readjusts, I get better resolution. I scan down at the bottom, which is the coolest environment, I let the camera adjust, I can see even better. So your search crew is searching quickly, you're scanning slowly, letting it readjust, reset based on the focal point, the temperature of that room. I'm doing my tactical 360, I come up on the C side of the structure and I see this in the window. Now, why do you think I could see that through the glass?
They're a little cooler heat signature than what the room is.
They're pressed up against the glass trying to get out. And their cooler heat signature is showing up cooler, as you said, and then the smoke filled environment above it. It's actually two firefighters up against the glass of a burned building. I already got a ground ladder thrown. So that's information you didn't have before. So how many of you have a bullard with the thermal throttle on it? Anybody? Okay. The misnomer I've run into with people using it is they're using it inside the fire environment during active fire conditions. The danger in doing that is that it only indicates the hot spots. It doesn't do color palettes. And the guys are like, oh, I love the thermal throttle. I can automatically see where it's the hottest. And I was like, yeah, and you can't see squat elsewise. So right now I'm the incident commander and I'm using it. And I was having trouble IDing where this fire was at because I got a really tight sealed up building. It's a great chance to use the thermal throttle for size up because now I see I got hot spots on the top half of the ground floor window and of the second floor window. So I've got fire extending through that floor into the next one possibly, where I didn't have that before. So my advice to you is beware of the function and the mode and don't use it outside of its proper context, just like using a camera that's not intrinsically safe in a flammable gas environment. So you can use it, but be aware of what it's going to do. Remember we talked about earlier, understanding the language, TT, thermal throttle. That means it's engaged. 0 to 100, it's at level 19. According to Bullard, there's no significance of that, but basically what I learned is it has an aperture or an opening, and the wider that opening gets, the more it makes everything blue. So that camera has an aperture of f1, which means it's really fast. So if you scan that, move that camera around too fast, you won't get an accurate reading, but with a bullard, it will readjust and refresh faster than most. All right, let's talk about real world stuff. 360 degrees of information. This is what we talk about, high risk, low frequency, non-discretionary time. These are line of duty death, NIOSH report type buildings. You still going to try to do a 360 on a very large building that you can't walk around? Anybody ever done that? Ever tried to do a 180, motorized 360, drive around? Okay, this is an example. The reason I share this one with you is because this was a near miss for me. I'm in a department, and the truck that I ride on, the engine I ride on, we do a lot of fill-ins, which means we're close to everybody, and when bad stuff happens, we end up going on the second alarm or move-ups. In this case, I typically listen to the radio all day, and this was after midnight. I was not listening to the radio, so I didn't hear the initial reports. This is information that should have been passed along. The first two companies that showed up at this 100 by 300 commercial structure, that was a bakery on the first floor, bacon on the second floor, and a tire store in the back, had full fire on the first floor. That information was not communicated to my crew and the other crew, which was assigned to go to Division 2, second floor, and attack the fire. You think that's important information to know? So you don't get that communicated to you, but you have a camera now. You got a good one. Say you got a great one. You're walking up and you start scanning the building. You see things like the smoke conditions and the exhaust points. You see the temperature of that. If you looked at these windows that they have nicely already breaking out, which are steel windows, casement windows, factory style, and you see on this end, right here, I got 500 degrees. And where I'm told to go, right here, I got 800 degrees. Where do you think the fire is going? Or where is it? Look at the ladder company right over here. Okay. I was fortunate enough to talk to the battalion chief before we went up, and he said, I think the fire is right here. He told me that, right in this area, below the ladder. So my guys go up with a search rope, get it to the top. They force the door. They don't have the line ready. You get full exhaust. They take the window out. It's 900 something degrees blowing out there. My guys know we already had our huddle because this is a commercial building. It's not your standard one. I look at that, I lay on the floor like I talked about earlier, look down to the left and right, immediately identify the fire is where the battalion chief said, because he's a forward-thinking incident commander and did what we talked about earlier. And it was approximately 12 to 15 feet in front of us where we saw the most severity. First crew comes out, we take the hose line, stay on the hose line with the search rope, moving to our left. Nozzle man's hitting the fire based on my direction with the camera, and then he says, I just fell through the floor. Guy behind him says, I just fell through the floor. Right leg through the floor. So we start moving and flowing, as Aaron Fields like to say, you got to move, you got to flow. So we're flowing and backing up. Temperature drops from 900 degrees to 200 degrees, out the door, guy's safe. We stop. When it's cleared out, we go back and look. Right here was a 10 by 10 hole in the floor. I couldn't see that with the TIC. I have to trust my guy's judgment, but I could see the thermal severity of the fire. I could see where it was, and I could tell it was getting better. You can't see everything with it, but it makes a big difference. So I advise you to take the information and use it to your best advantage. The reason it says cold spot right here, this is something I learned after the fact. This was originally a one-story building. When I looked at it from the camera, when I got far enough back, there's a 24-inch space between the first floor and the second floor that's dimensional lumber, like tree trunk size lumber running the length of that building, which used to be the roof. The fire started on the first floor, ran the wall, and burnt through 6 by 6 logs that supported that floor. It'd been burning a long time. So you can get a lot of information if you use the camera. We can't predict everything, but I'm trying to give you as much information as I can. Talking about now, next, future, past. I don't know if y'all do a lot of inspections and whatnot, but if you look at fire suppression theory on when they base sprinklers and whatnot, for every 18 degrees increase Fahrenheit, you get 100% increase in air entrainment and fire severity. This picture emphasizes that. You're moving down a hallway, you've got a doorway open from the fire room, say a kitchen into a living room, In 15 seconds, you have a 250-degree temperature rise. You think the fire in that room is significantly grown? Good nozzle man's going to do what before we go further? You're the nozzle person. Cool off that ceiling. Use the reach of it. How many of y'all use smoothbore or long reach fog nozzles? Have at least a 20-foot reach. We teach the public to pull, aim, squeeze, sweep at the base of the fire. We get all the way into the burn room and open it and aim at the ceiling and wonder why everybody's screaming, ah, that hurts. We just took whatever was above our head and put it down on top of us. You know, cool the ceiling in this case, and then aim for the base of the fire when you move forward. Wait a second, watch it lift, and cool it off and finish it off. You don't get the thermal upset, you see. It's, you know, you get that by using the TIC to direct your stream. We talked about language of the TIC. You can do, as you're doing your 360 here, you can see, we talked about earlier, he was saying, how can I tell whether or not that's exhausting out of the top half of the window? Look at this window. You see the exhaust on the lower half. You see the color palette that's pretty much saturated red. But at the top half of the window, I see the window is white, like a milk mustache or a heat signature. So I got a lot of smoke built up there, and smoke is fuel. If you haven't read Smoke Burns book by John Taylor, extremely recommend that one. It helps emphasize this point. Watch Max Firebox videos. He nails that as well. So I can see exhaust on the bottom. Top pane has not been busted out yet. And I got extreme heat in that room. All right, how many of you got balloon frame structures? Anybody deal with that? The reason I emphasize this is a lot of times we read the fire wrong and we say we got turbulent black smoke coming out the second floor window. You may not have a balloon frame. You may have lightweight truss that fire spread up that. You think it's on the second floor, but then when you scan it with the TIC and you realize that I have a fire down here and not up here. Any of y'all had the misfortune of stretching a hose line to the wrong place? It takes a while to reposition. Yeah, me too, Chris. I've messed up a lot. I'm gonna throw myself under the bus more than anybody else. So as they say, so goes the first line, so goes the fire. Well, I've had a so goes uh-oh, and boy, playing catch up is a booger. It's not any fun. So we want to try to do a very efficient size up so our guys and gals can make a quicker, more efficient attack. And in this case, you can tell whether this is a basement fire. There's a Bilco door at the bottom of the ladder here underneath there, if I'm correct there. This is my buddy Jim Moss took this at the NIST burns. It's a good example of that. So let's talk about three-dimensional factors. These are your variances, exceptions, things that hurt or kill firefighters. When you're doing your 360, and you ever thought about looking up to see where the power line is at night? You ever seen a down power line through the eyes of a thermal imaging camera? It shows up really well. How many of you got chain link fences around your houses? Power line on a chain link fence, firefighter carrying a 16-foot ground ladder, walk around the side, puts his hand or her hand on an electric fence. It's been documented cases of firefighters being injured or killed touching charged electrical things that were not normally charged. Okay, this is an overheated transformer that had a down triplex line that run to the house. So the incident commander, you can see that if you take the time to not only scan the structure, look for power, utilities. What if all of a sudden you're walking around and you see like, looks like a vapor cloud coming from the backside of it? It's cold. Any of y'all got fuel tanks, propane tanks, things of that nature? That's pretty common where we're at. I got a leak of some kind coming around there that I didn't know I had before. So you can use it for hazmat. I can identify victims that may have jumped and laid out on the floor or ground. And also if I know in Chris's area, I bet you got houses 8-10 feet apart in some areas, don't you? All right, so I got thermal exposure. You got stucco, which absorbs heat pretty well. I can use that camera to tell whether or not that structure is about to light off. Do I need to put another line on there to protect it? Those are things you can think about. Three-dimensional factors. How many of your builders are using engineered lumber now? All right, what do we know about that? How fast does that fail? Okay, so if I know that the neighborhood we're going to is TGI or engineered floor joists, roof beams, lightweight truss, like I call toothpicks, popsicles, and staples, right? and it's got lots of glue, and they've got basements in them, and I've got multiple calls, heavy fire and smoke visible, does that change my game plan now? Am I going to be aggressive about putting firefighters above a fire in a engineered lumber structure that is basically glued and laminated together that burns much more quickly and fails between 6 and 13 minutes from ignition, not from when we arrive? Okay. This is what these things we need to consider and know. If you've been pre-planning and looking at your area, you can see that. And another thing with the thermal imaging camera is if I scan the crawl space of an environment, if you have those, or basements, and I can see significant charring of the floor joist where I wouldn't normally in like 2x6, 2x8 construction, I'm looking at something different. I'm looking at OSB, TGIs, whatever you want to call them. They're all kind of different names. Pay attention to that. So a lot of people don't think about it. Oh, I got a crawl space, open the door, do a quick scan. Okay. Ooh, there's something I didn't see before. That's composite wood joist. Just something we need to think about. I told you before, my company does a lot of fill-in. This is a second alarm apartment fire. We were assigned to go in for the mop up, put the fire out deal. My guys are nice enough to let me do a quick look before they go to work. I scanned the stairwell entrance point where they want us to go, looked up and saw what I just told you, which was the floor joists were burned up. So I didn't want to step there, walked around the back, looked at the seaside, and saw the same thing on a cantilever roof. The reason that's important is because this is what it looked like during the daytime, and there was no floor right here. I fell 3 feet and was out of work 6 months. How far do you think I would, or how bad would it be if I fell 8? These are things we can predict, and if Gordon Graham says if it's predictable, it's preventable. So all 3 perspectives, gentlemen. We're looking at our tactical, thermal, and we're looking at 3-dimensional. Guys and gals looking at the fire ground, you got to look at it differently. And just like in that picture on the left, you can see things you wouldn't normally see with your naked eye. Here's an application of a ranch house. We're doing vertical ventilation, not without a thermal imaging camera. They're cutting a vent hole. The fire is actually 10 feet to the right. Small house, may not make that big of a difference, but it was an electric fan that failed. They left it on. It burned up and to the right, not to the left. Now, I just cut a vent hole to the left. Where is the fire going? You ever took a thermal imaging camera to the roof and scanned it? You can see the roof joists. I've had one white out on the roof off an aerial. Guy poured gasoline in the attic and then down the stairs and out the back door, behind on his mortgage payments, wanted to pay it off. And it was 1,100 degrees before the camera did what he said about whiting out. Camera whites out, that means you're out. You know, it's 1,000 degrees or more. The camera's saying, I can't take it, do something about it. Either put lots of water on it or remove yourself from it. So pay attention to that. All this does no good if you're not passing this information along to your guys and gals, whether you're teaching it or whether you're the crew leader and you're not communicating to them what you're seeing and what they're dealing with. You're the interior crew making the attack. The incident commander needs to know what you're seeing. Pass that information along. We talked about we're going to do go, no-go decision making. Well, you know, y'all heard that? Heard about it, what it is? A lot of people get upset because they think, oh, they're saying we're not going to go in at all. No. You're saying you're not going to go in until you do something about it. You know, I don't let my daughter ride a bicycle without a helmet. Not because she probably won't get hurt, but I don't want her to get hurt. She's like me. She's got good looks from her mama, and she got her lack of coordination from me. So she's going to fall down. So before I go into a burning building, I need to know certain things about it. Is the temperature less than 500 degrees? Is the neutral plane less than 50% of the space? Is the smoke turbulent or non-turbulent? And can I see all that information on the TIC? As Chris said earlier, is the camera whited out? Is it saturated? If it's not any of those things, then I can move forward with my attack and still be in my thermal protective performance of my gear and the things that I'm carrying. If it's greater than that, then I need to do something about it. I need to cool it off. I need to close it down, shut it down, hang a curtain, all the different things you can do to make that better. Those are simple decision-making model that you can do at the front door, moving down the hallway. You do it every space you move forward.
That's really good information too, Andy. And like you said, this information needs to be passed on. And I'm trying to retrain myself from everything we've learned. But when we start our tactical 360, we started at the front door. Like Andy said, if it's closed, I open it. I look in and I read my neutral plane, read this go, no go data. And then when I replace that door with either a curtain or the door itself and finish my tactical 360, I relay that information to the next incoming crew, whether it's mine or the second in unit. And as they do that, if I tell them, hey, I've got all the flow paths isolated on all the sides, I've done a complete 360, my neutral plane was 2 feet below the door, then they know that when they open that door to go in and make that fire attack, if we're not doing a transitional attack, hey, conditions may have changed. They have that data that I initially took to go by. So when they open the door, if we have a neutral plane that's significantly different than what I said, we have significant fire behavior change or some type of catastrophic fire event. So all this information, the go, no-go data has to be relayed to your second in crew. And we are blessed to have a ton of staffing, so it might not be me going in. I can barely get an on-scene report out without having 3 units on scene, all staffed with 4 guys and a battalion chief with a safety officer in 3 minutes or less. So I make it a point to try to relay this information if I can.
And you bring up a good point. All this happens very quickly. So, you have less time to do what you do. So you got to do it better. You got to be fundamentally sound. Don't get me wrong. If you're not doing the fundamentals right, you don't need to be even playing with this. Can't throw ground ladders, can't advance hoses, can't put your gear on right. This is not, we don't even need to be talking about this. We need to be hitting the fundamentals hard. All right. So when we're doing our access or our go, no go, we need to know what these indicators are. And then we need to be tactically proficient enough to apply those skills to put those out and make the save or save the structure. So when we learn to detect what we got in front of us, here's an example of just a simple little thermal cue you saw on the window. This house is tightly sealed up, even though it's an older home. You see a signature above that doorway. I always say, what's behind door number 1? Well, I bet I know now. I bet if I open that door and I don't have my hose line charged, I don't have my crew ready, by the time they are ready, the fire is going to be significantly worse. So, you put a lid on a pot when it's burning to put it out. Keep the door shut till you're ready to go. We had an incident with a hotel-style apartment where we were making a stretch with our high-rise packs. Guys are making the connections, and one of my guys pushed the door open. It went from a beautifully clean hallway to 0 visibility, and we had to make our connections in the dark, even though after we shut the door. They weren't happy about it, but they won't do that again. So don't do it till you're ready. So how do you see the fire now? Is any of this, quick Q&A, has this changed any of your perspective before we move forward? Have I cracked any doors? Have I made anybody mad? Am I ready to be burned at the stake? I mean, some of this is heretical in some sense, but let's face it, guys and gals, technology is going to be a part of our world. We don't have to rely on it, but we need to understand how to use it. Your fundamentals are always the fundamentals, but you need to understand that our world is changing. And if we don't change with it, the dinosaurs didn't change, they're gone. So we have to move forward and embrace the technology and how to use it efficiently. So has this changed any of your perspectives whatsoever?
Absolutely.
Anybody got any epiphanies before we move forward? We're going to hit some hard points here in a second. All right, so how do we see the fire now? Here's my good buddy Stefan Fuchs from Germany hanging a portable door, as Chris talked about, the front door. Now look at the picture on the right. When you optically is on the left, that's where he's hanging it, right? Now, look at the difference and where he's at. Now we learned earlier that in the camera, the Bullard camera, red is around 1,000 degrees. In this camera, it's about 500 in this specific shot. You know what he said when he was done? My hands hurt. It's hot. You won't put your gear there very long. That's the upper end of that spectrum. So he's even hanging a curtain and having trouble. So you've heard of 3D in the door, cooling off the door. This had been a good chance to wet the door frame down, cool those gases, cool the door frame, then hang the curtain. Another example of that. So your key points, what you need to learn. And what I've learned so far is keeping a tactical perspective. Dad taught me a long time ago when I first got promoted to captain was the hardest thing I'm going to have is I'm going to have to learn to let them do the job and me watch over them. That's very difficult for me because I'm hands-on. I want to get in there with them. But if I'm taking blood pressures at a medical call, am I watching for the crazy guy coming from the back bedroom? I'm not. Tactical perspective means I got to be far enough back to see the big picture. Whether you're the incident commander or the crew leader, your job is to watch over them. Their job is to tactically do the job and put it out or do whatever they're there for. You're not to be doing it for them. You're supposed to be making sure they go home safe. Yes, you can hump hose. Yes, you can read the thermal imaging camera. You can carry a tool, whatever you're comfortable with. But if it keeps you from watching over them, there's a reason why an officer's tool is no longer than 14 inches. FDNY did a study and figured out that if I carried something big and bulky, I'm looking at the tool. I'm not looking at them. So make sure your situational awareness and your tactical perspective is that I'm seeing the big picture and watching after my crew. You know, what we hammered earlier is you got to stay oriented. Did you read the building? Did you count windows? Are you counting doors? Do you know how far you're in? Are you on a hose line? Are you on a search rope? Do you have a secondary means of egress? That's important. And you're continually reassessing that environment. I think what he said earlier about the firefighters getting burned. Went inside, camera whited out, kept going. You know, you ever had that little voice in your head say, hey, knock, knock, pay attention, this is important. That's what that whiteout is. This is important, you're gonna get burned, something bad's about to happen. I'm not even working in this environment. By the way, you won't either. Here's an example of a standard traditional attack with not controlling the flow path, pushing through the front door, fires to the left. What you look at firefighter crew leader's head right here. Where is that? Is his head in an area where it's going to get hot? Yeah, well, that's my bald head. So I throw myself under the bus there. So our PPE limitations, we know what they are. If we give the fire more air, we will have more fire. Where will it ignite, you think? What do we learn about neutral planes? This is where it's going to ignite. The exhaust portion is getting air here. It's going to light right there where I am, where they are. All right, let's talk about our perspectives again. We're going to hammer it home. We're going to be done here in a minute. We're going to get to the search and be done. But your now is your imminent threat. If you're looking at this structure, this is a high resolution camera, one of the best on the market. They say you can't see structural integrity loss. Tell me if you can see anything in there that says that this structure is about to fail right there. Anybody? Think fire's above you in that porch? Anybody?
Mm-hmm.
Okay. What else do you see at that front door?
The corner's starting to burn out. You can see the security door in front of it.
Yes, a good point. Which direction's the fire spreading? Left to right, right to left, straight up. Where's it going?
It's coming left to right.
Good. All right. I'm inside making the push down the hallway with my guys and girls, and I'm the crew leader, and I'm assessing the thermal severity of where I'm at. What can I see in this picture that's important to know?
You can see the neutral plane, how low you need to get,
Mm-hmm.
and or you know where the fire is. I mean, that's a Connex box, so
Yes.
you can
Very
see
good.
that. But you can see all of that information.
What's the color palette say? What temperature range are we in?
I guess it depends on your camera, but that's 800 degrees for us.
Somewhere in there, we're between 600 and 800 degrees above
Mm-hmm.
our heads. What do we learn about scanning our firefighters' gear? What's happening in their gear right now?
It's becoming more and more saturated. So with the heat transfer, we just talked about this the other day with my engineer is Mike Davis, and we were talking about the heat transfer when we were cooking a turkey yesterday. But convection and radiation is the majority of your heat transfer, and that's what you're absorbing the energy with. And you can monitor your firefighters' equipment just by doing that.
Mm-hmm. So your face mask, would you argue that that's the most important piece of your thermal protective performance? Can you do anything if you can't breathe?
Nope.
All right. So right here on the front part of his mask is absorbing a lot of heat. And if you've watched any of the studies like Adam St. John's and any of the other ones they've done, When those masts fail, they start with a small opening after they go wavy, wherever the heat was concentrated the most, which is usually which direction you were facing. Wouldn't it be, if he's taking that much of a beating right there, they need to cool that environment off or need to switch positions, get in line, do something differently. Because if you read much about contact burns, that's how that happens. All right, so we talked about PPE saturation. His helmet and face mask is getting saturated. The neutral plane height, as Chris pointed out, it's coming down, which is not a good thing. And if I look at the color bar graph on the right-hand side, this one goes red is in the 1200 degree range. If I look in the far right-hand corner, I see red, which means thermal severity ahead. So I want to use my stream, reach of my stream and make things better, not crawl up in there and then try to put it out. My crew's moving down this hallway. I can see things I couldn't normally see before, like there's a superheated environment ahead of them. So I checked their gear as we talked about, and I used the reach of the stream. Many of you have taken the nozzle forward class. What does he talk about when he says using his stream techniques? Wall, ceiling, wall, and what? Sweep to floor. Now, if I do that with water where I'm at, do I have any chance of that burning? Where I'm at, if I put a thin layer of water on that wall, the ceiling, the floor, do I have to worry about any of that right there? Not typically. If I put enhanced water like KTF advocates, it actually sticks to where it's at and stays there, creates an area of refuge. So wherever I'm at right now, I'm going to make cooler and better and safer. Where I'm going next, I'm going to cool off and use the reach of my stream. And what the future looks like will be better. And then I'm going to look behind my crew to make sure it's not getting worse or changing. Moving forward, same thing. I can see where it is. Is it progressing towards me? Zero visibility previously. Now I've got a better indicator of what I'm dealing with. I'm pushing up the top of a stairs to do a fire attack on the second floor. Optically, before without the camera, this is all I would see. It's a smoke-filled stairwell. But with the camera, now I see this. Why not use the reach of your stream, cool that environment off before you get up in there? You don't have to be on top of it to put it out. So you need a stream. Sometimes the TIC is the only thing that gives you the best indication of that. So our past gives us a lot of information. If I just did all that stuff we just talked about, and now it is getting worse than what I originally saw, my past picture of it, do I need to change my game plan? What I know about this type of building construction, this type of fire, what does my past experiences tell me that if I don't change what I'm doing, what's my current conditions versus past conditions? It's just if you've ever taken a class where you talk about tactical slide trays in your mind, here's what I had, here's what I have now. Is it getting better? Is it getting worse? So we're talking about implementing what we do using tactical TIC use. The picture on the right is the room that your firefighters are supposed to conduct a search in. Zero visibility whatsoever. And the picture on the left is that hot, which is upwards of 1,000 degrees. 1,004 by the spot temperature. Don't commit your crews into something that's just going to get them burned or injured without cooling the environment off. Close the door, do something. You have the power to make that difference now. So we're moving down the hallway. We need to do this as crew leaders. We need to assess the actual environment. We need to condition or cool it off. And then we transition, we move forward. And then we repeat. It's as simple as that. You've been all taught how to advance hose lines and how to move forward. But a lot of times if you watch, many of them are just going as fast as they can down the hallway. Well, they didn't do anything to that environment other than pass through it on the way to where they're going to make that better for them. Or if somebody comes out of a bedroom trying to get out, you got to think through this. We're thinking firefighters, and we're not just Mongo put out fire. We're going to cool this off, make it better, and make it better for anybody else. When we talk about scanning, we scan high, we scan medium, we scan low. And the reason we do that is because the thermal severity is typically above us. We can see where the fire's in the attic. Any of y'all had the pleasure of dealing with what they call easy joists, 2x4s with just little metal brackets? They show up really well in thermal imagers, and they light up pretty quickly under fire conditions. They fail very fast. They're using these in floor joists, roof joists, walls. We have what they call podium style construction in my area. You see these everywhere. They're very cheap. So we learned that with the TIC, I can facilitate a direct path where I need to go. I tell you my daughter's over here in that left bedroom and you guys are going to do a right-hand wall search, and you quickly as the crew leader identify where that girl is, are you going to make them do a right-hand wall search? You're going to make them go straight to the girl and get her out. Why am I going to waste time? Get the person, get them out, have somebody else finish the search properly, because there's areas you can miss and not see with the camera, but get the person you came to get and get out. Just like people talk about cutting a vent hole. Cut the vent hole, get off the roof. Don't admire your work. So I'm moving down a hallway. I'm not sure if I'm moving towards the fire. Now I can tell that fire's coming out of that room. We talked about that V that you see that's characteristic of fire growth. It's coming out of that room and starting the radiative feedback, heating those gases on the ceiling. By the way, do you know what plaster or sheetrock, what the emissivity rating of it is? Remember we said emissivity of a 0 is like a mirror, and emissivity of a 1 is like the perfect thing to absorb the heat. Sheetrock is closer to 0 because they want it to be energy efficient and anything that's put in that room to reflect back, just to keep the energy in. So if I got a fire below it, it goes up and radiates down really quickly like a mirror. That's what it's doing. So my guys are about to move into this room. The fire room next to it is flashed over. What we talked about earlier, if you see the couch lighting up like this yellow you see here, what is that an indicator of?
It's the beginning of the off gas.
Okay, what are couches made of?
Oof, pleather, microfiber, some type of cloth material usually.
What is a cushion made of?
What's what?
The cushions, the things you like to sit on. What is all that soft stuff made of?
All synthetic mostly.
Polyurethane, which is nothing more than solidified gasoline. What do you think carpet's made out of?
Same stuff.
Same stuff. Do you think the ignition points are about the same? So the carpet that I'm about to crawl on is over 300 degrees. Have y'all ever had the misfortune of putting your hand on a Naugahyde or vinyl couch that's over 500 degrees with your really nice firefighting gloves? It becomes one with your turnout gear. And I don't care what kind of gear you got. If you put something hot on you and leave it there, it eventually will burn you. So when your firefighters are searching and they're taught to search couches and beds, and you tell them, that couch is 600 degrees, don't put your hands on it. Cool off that floor, wall, ceiling, wall, sweep the floor, air and fields, nozzle forward, basic stuff that we all should know. But I just cooled off that floor before my guys and gals crawled on it. Okay. I'm cooling off the lower 48 inches, which we teach the public to do in extinguisher classes. And when that cools off, all that wonderful vapor from that steam rises up and naturally lifts that neutral plane. And I don't get the thermal upset that I would if I typically did a TZO pattern, whatever you want, to the ceiling and inverted all that back on my head. I tell you to go to the second floor and search for an autistic child who is hiding somewhere upstairs. You don't know the layout of that second floor. People like to hide. They hide in closets, bathrooms, whatnot. You're the crew leader. They're moving up the top of the stairs. This is what you see optically. This is what you see with the camera. There's the closet. Go get them. You know, this is information we need. If your department spends good money on your equipment, use it. Learn how to use it. Don't be just against everything that comes out. Learn about it first, use it efficiently, and move forward. Here's an example of tactical TIC use, understanding color palette. In this camera's example, dark gray and black is over 500 degrees in this mode. So don't always associate certain colors with safety. You need to understand your camera's color palette. Each camera, unfortunately, is not the same. I wish they were. If they used the TI basic format that NFPA recommends, they would, but not all of them do. The temperature inside that room is over 1,200 degrees. That's zero visibility. Go ahead.
I got a question about our Bullard modes. You're talking about the two modes, the low mode and the high mode. So the 0 to 200 and then the 200 and above. We're going to be able to see that E1 mode. Are we going to be able to see when it's in the lower mode?
E1 is the lower mode. It starts high sensitivity, which is counterintuitive to our thought process, but your starting mode is a higher sensitivity, lower temperature range, 0 to 200 degrees.
So that's the E1 that we see?
The EI is what it actually is electronic integration. You see it in the upper left-hand corner, means that you are in the higher temperature range or lower sensitivity of the camera, which means the majority of that environment is over 500 degrees.
Okay. And what's our indicator when it's in the lower sensitivity mode?
There won't be any indicator in the upper left-hand corner, but the color palette will be predominantly gray.
Okay.
Unless your camera has super red hot, which means that anything that's over 1,000 degrees, it will automatically color it red.
Okay.
We do have that. We don't have any EI indication on ours either. I think the newer ones do digitally in the corner, but ours won't say electronic integration, Mike. It just goes right into what I refer to as tactical mode. And then if we want to go into thermal throttle, then we can get into that higher resolution, but we have to physically do that. And in order to get out of it, we just push the 2 buttons down. But we go right into that advanced mode where our color palette will change automatically for us.
So if we
Just
hit
like we were looking at the stove the other day.
I'm sorry.
I was just clarifying something. So if we hit that thermal throttle, that puts us into that lower mode, and just hit the double click, and that'll reset us, and we'll go back into tactical mode automatically.
Thermal throttle, I'm going to reemphasize this, should not be used inside of a fire environment except for overhaul or size up.
And we can't do it anyways. Anything, when it basically saturates the thermal throttle, our whole camera lens will be blue.
Exactly.
So, and we won't be able to adjust it. And unfortunately, it won't switch right over to EI mode. So you have to reset it by either dialing it all the way down to the 0, and you'll watch the TT at the bottom that Andy had some of them in his slides. That's the only reason, the way we can identify thermal throttle mode, or just hit both buttons simultaneously, and then that will go away.
Okay. I was wondering how to get out of that mode in case we bumped one of those buttons on the top or something like that. How do we get back to our tactical?
Just push it.
And that is why I am very strong advocate of cameras that are very simple and easy to operate. The more buttons and modes it has, the less I think it's efficient inside of a fire, because if I bump something and move it to a different mode, change the color palette, change the setting, how hard is it for you to reset that in a zero visibility environment when you're supposed to be watching over your crew?
Like our new radios.
Yeah, that's a good point. So it needs to be something that can easily operated with a gloved hand. And why I kept zooming in on this triangle is because the majority of cameras today are embracing NFPA 1801, which gives you a triangle indicating it's in the lower sensitivity mode. You will see that on almost all cameras in the future. If you want to learn more about that, I can send you the link on NFPA 1801. You don't have to be a paying member to read that standard. It's pretty simple. It's image quality, interoperability, and durability is what they base it off of. And some cameras meet the specs, and they're not NFPA approved because they didn't spend the $100,000 and send them 5 cameras. But you got to know what that's for.
We have 7 new ones in our department. I don't know where they're at. We did the Bullard Exchange program.
You got the factor upgrade.
A great program. I don't know where resource management put those 7. But 7 of them have the newer optics and digital readouts. If I can get my hands on one, I could be a little more accurate with it and teach it, but I don't know where they're at.
Yeah, and that's the point that I try to make with this. As much as I can tell you about cameras, they're yours. So you've got to be proficient with your camera in your department, and especially how you do business. Everybody has different SOGs, different operating guidelines and tactics. And, I can tell you the outline of it, but if your department applies it differently, you need to know that. Like in this example here, the firefighter's crawling. He went through the fire room and is now moving away from the fire and does not know that. The fire room's to the left. Look at the heat signature on the bottom left-hand corner of his or her boot. It's pretty hot where they went. Color palette's maxed out. They moved through a superheated environment, didn't even feel it with the gear, didn't even know it. That's a problem. Here's an example of why people are advocating vertical ventilation. I'm not going to argue for or against, but I want to give you 2 options. Here's vertical ventilation where you pop the top, fire coming out nice and clean, right? Here's tactical air management or anti-ventilation. Same thing, nasty smoke coming out the door. We hang a curtain. Look at the difference in the visibility and the fire decaying. Same effect. Just tools in the toolbox. Depends on what you're able to do. We talked about that shot earlier about them closing the door. Here's 2 side-by-side shots. Before, the room was over 1,000 degrees. They closed the door. The max temperature in that room was 518. It was less than 200 at the floor just by shutting the door. And that's all done by looking at it through the camera and saying, okay, now it's changed significantly. We can move forward. We can do this, or we can't do that. We don't like being told we can't do something. I'd rather you look at the actual proximity of where you are, the limitations of your gear, and understand your gear is proximity gear. It's not designed for direct flame contact, and it has limits to it. And for us not to recognize that is not only ignorant, it's stupid. You know, we got kids, we got wives, we got people we're supposed to go home to. I'm not saying you ain't going to push it when you have to, but you need to understand what your gear will and won't do, because if you don't, ignorance is not going to help you in the burn center. We can use the TIC to direct our stream. I mean, I don't know how many times I've been in places where they open a nozzle and they close the nozzle. How do they know the fire's out? Well, it cooled off. Well, to what? Based on your temperature you feel on your ears, your gear, your air bottle, the air you're breathing cooled off. What? I got a diagnostic tool that can direct my stream to where that fire's at. I can hit my hot spots when I'm doing my overhaul. I can hit that. I can see things I could never see before and make sure I get everything. I don't know if any of you had the misfortune of having to go to a rekindle. That's not any fun. I get 2-day vacation for that. You know.
Only when we come on after B shift.
Thank you. I'm on B shift. Appreciate it. I'm glad there's some off shifters here.
Andy, I don't know if you're going to bring it up or not, but I know you brought up a really good point when we were actually, you know what, I'm going to wait because it probably is in this section, enhancing the search. So I'll see if you bring it up first.
Yeah,
so
this is the last portion, so bear with me, gentlemen.
Okay.
We've all been taught to do searches. I don't know what your favorite kind is, but everybody has different ones depending on the occupancy and your staffing. But basically, before TIC use was implemented, we found the victim 60% of the time. After TIC use was implemented, we find the victim 99% of the time. And that includes rapid intervention scenarios with firefighters, okay? We've been trained incorrectly. Typically, when it comes to doing search methods with TICs, we train in cool environments, fake smoke. We've trained in our bedroom or bunk room. Yeah, that's great. But at the same time, it's not a superheated environment, so I'm not going to get the same effect. What I was trying to emphasize earlier is a 98.6 degree person is not going to show up with high contrast unless you've got a super resolution camera that automatically adjusts quickly, which most people don't, because that's about a $15,000 camera. So now I'm looking at what I got, and I can't see my firefighter. So I need to learn to look for shapes, feet, hands, helmets, air bottles. What color do you think an SCBA is going to be in that room? Right there. If the room's all hot and red and yellow, why did I tell you to look for cold spots earlier?
Yeah, it'll be dark because it's expanding gases will be cooler.
That air bottle is going to be the coolest thing in the room. That's a big one when you're looking for a downed firefighter, especially if they're underneath something, because they're not going to be in a pretty clean open space with nothing around them. They're going to have something pinned on top of them. They're going to be trapped, mask off. It's not going to be easy. It's going to be worst case scenario. If somebody's down, it's because something bad happened. You need to be able to recognize, okay, the last report they had was in the Alpha Bravo Division 2 corner. That's all I know. So I'm going to search like we taught to search, but I'm going to look very closely for dark spots, things that he or she could be buried under, hidden. And I'm going to look for shapes because you don't want to miss them. All right, so we talk about enhancing our search methods. We want to make sure it's safe to crawl. We're all crawling, whether you're doing duck walks, hands, knees, nozzle forward, clamp slide, whatever you're doing. You need to make sure what you're about to put your body on is not exceeding the thermal limits of your PPE. So great shot from NIST here on the left, firefighter crawling towards a burning couch. Do you think that person wants to crawl over here to the right on a 300 to 400 degree floor for very long, knowing how fast carpet melts? You ever seen carpet melt, what it does? I had the misfortune of having a styrofoam cup melt, same thing. It's going to stick to you. It's going to burn your knees, burn your thigh, whatever it is you touch with. So when you're doing your searches, you got to be able to watch out for your crew and look at this environment. Say, this room's about to flash over, the floor's over 300 degrees. I need to cool this off before they move forward. And if I don't have a hose line, maybe I should shut the door to that room, wait a few seconds and see if it gets any better before I try to move in there. Here's your scenario, ladies and gentlemen. How many of y'all done directed search scenarios before? How many of you currently know the resolution of your camera? What is it? Is it 160 by 120? Is it 320 by 240? Anybody know? Okay, the two Bullard cameras that I looked at that you may have, one of them is a 160 by 120, one of them is 320 by 240. The reason is they're searching a living room den area. You're at the doorway, you're the crew leader. What can you gain from this information looking here? This is open game. You throw it out there and we'll talk about what's actually in the room. What do I need to tell my crews about the capability of my camera? This one in particular is a 320 by 240 resolution, and they're doing a right-hand wall search. They're currently at the couch, checking on top of the couch, moving around the room. What can you tell about that room?
You can tell them where the neutral plane is. You can also tell them that, depending on the size of the room, that you're only potentially seeing some of it. So whether it be 25 feet max, and where your resolution seeing something as small as the child's hand at 15 feet, but you tell them to stay lower and how far you can see to keep them safe. If they're going to move out of that field of view, then you need to move yourself so you can get that a little better.
Okay, good. Anybody got anything else to add?
You see that wall indents back.
Yeah, it's a recessed area. Very good. Anybody else?
Another thing that I'm kind of looking for too is is hinges and doorknobs. You can usually see those pretty good through the TIC once they get superheated. They light up a little bit, and then Andy brought up a good point about wetting the door at some point. I'll let him hit that.
Okay, so, all right, I'm moving down the hallway. We're about to search this room. We talk about staying oriented and locating and always having a secondary means of egress. We're all taught follow the hose line out of the fire. Smooth bump to the pump, something I was taught. All right, if the front door is not controlled and the fire light's behind me, do I want to go back out through that front door? I'm not. So I'm cooling as I go, having my guys cool it off, and I'm having them wet door frames and doors and closing doors as we go. So I counted 2 doors to my right as we moved in. Now we're moving into a den. Something goes bad, I can move back 1 doorway, go into that room, and I've got an area of refuge, and I see that dark spot on the TIC pretty clearly because the door's wet. Okay, that's one example. In this room, I'm at the doorway. I don't have the door closed. Look right here. Neutral plane, air intake at the bottom. So there's significant heat above their heads in that recessed area that somebody pointed out earlier. Why don't I just move to that door and close it and stay there and guard over them or watch over them that way? A 320 by 240 resolution camera means I can see effectively up to 15 feet. So do I need to be within 15 feet of them at all times? Because if they get further than 15 feet away, I can't accurately guide them and give them a good eye of what they're looking for. Same thing if you got a lesser resolution, you got to be closer, got to be 7 to 8 feet. Okay, so they're searching. They got significant heat conditions over the top of their head back to the left. The door's open. It needs to be closed because the heat is moving into that room from the left. I can control that. I'm starting to see some radiative feedback on the walls, and it's starting to light up and come down on top of them. If I don't close that door, it's not going to make it any better for them or any victim that's in there. I scan high, I scan medium, and I scan low, but I've got to move slow enough. You see somebody waving a TIC around like an orchestra conductor, they didn't really see anything. I've seen people do 6-sided scans that look like they were trying to conduct something, and you didn't see nothing. It's like if I took my iPhone and I tried to take a picture of this screen really quickly and moved it around, I'm going to get a bunch of blur. Your camera has a refresh rate, a certain amount of hertz, just like a computer, that it has to reset. And ever so often, it will calibrate or recalibrate, which the screen will freeze, which means you moved faster than it could assimilate the image, and it will shut the shutter, not take a picture, formulate that picture, and then start over. Okay, and that can happen every 30 seconds to 3 minutes, depending on the temperature and how fast you're moving. All right, what can you identify here about these firefighters in this environment they're in, real quick?
Their gear is absorbing some of the heat. You know which direction the fire is?
Which direction is the fire?
To the right.
Very good. What mode's the camera in?
Low.
Sensitive mode.
Low sensitivity mode. We're in the touchy-feely firefighter mode, right? So fires to their right, they're absorbing all that heat. I need to do something about that. All right, key points for you to remember, and we're done. Remember, you need to understand and know your TIC. Before you leave today, I challenge you to go find your owner's manual and find out what the resolution is, what its max capacity is as far as the temperature, the color palettes, the modes, what your department uses it for, as far as what mode they use it in. And if you're going to be the crew leader and you're going to watch after your people, you need to get used to putting that TIC on your gear every time you get off the truck. Every time. It's aggravating at first, but after 40 days or so, you'll get it. You need to practice this use in high heat environments. If you got burned buildings, you got areas you can practice in, please do so. He brought up good points about doing it in the station. If you want to find out about the value of insulation and what you can't see, get one of your favorite buddies and have them get in the bunk room, cover them up with a bunch of blankets where all you see is the top of their head. Search the bedroom and see if you can see them, because all you'll see is the top of their head. Why that's important is because we find people in the bed, unconscious or deceased, and we don't see them with the camera because comforters are great insulators. They don't show heat, right? All right, you need to stay oriented and know your TIC's limitations. And the last two I want you to emphasize is you need to practice, 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 and you need to watch thermal data online that's representative of what you see. Don't watch another video of a camera that you're not using, because you're going to say, well, I'll see this. No, you won't. If I look at ISG videos all day long and I got an MSA 5200, I'm going to get spoiled looking at ISG's videos, and I've got a black and white camera. I need to be good at the grayscale imagery. You can learn more at our KTF Burns account on Twitter or on Project Kill the Flash over on Facebook. There's a private group you ask to join there. That's over 2,000 members in 28 countries. You can ask questions about this each and every day. Killtheflashover.com. If you become a associate level member for $25 a year, you can have access to a lot more information like this. I post articles on Facebook on this as well, and Chris shares a ton of information through his stuff as well. And here's my contact information. I'll leave that up. Sorry I ran over a little bit, but I hope you got something out of it. Payday for me is when you guys contact me and say, hey, I did this. This worked. It helped me. I like to hear those stories. So if you find something that's neat and interesting to do with it that I hadn't thought of, please share. One last tidbit somebody gave me I thought was pretty cool was, remember field of view? I said your camera's 37 by 50. 37 degrees is your top to bottom. I'm in a big great room. I'm only going to see a small portion. Turn it to a gangster grip, turn it to the side. Now I'm looking at 50 degrees top to bottom. The camera doesn't reorient it, but you can see a lot more that way. I got that from somebody else, so I can't take credit for that. Any questions, ladies and gentlemen? Was it?
No, I don't. Go ahead, Chris.
Even there's one person that asks a question. Right.
I'm sorry?
I thought Chris was going to ask something. No, I really appreciate you taking your time, Andy, doing this. And I know our kids are usually jumping up on our laps, drawing pictures for each other when we do this. But I really can't thank you enough. And the guys on here from the Fools, we do this every 6 weeks or so. So if you guys want to jump on, if there's a way we can get it out to the membership, that would be excellent. Usually we do it on Google Hangouts. I started to post things. I know I'm probably one of the newest chapters, but I started to post things on the Facebook and my website.